Today's session, as stated yesterday, will be more hands-on and technical, giving us the opportunity to engage deeply with some of our sensors we have. So we'll move right into the first presentation for the day. Our first presentation is themed Introduction to Data Pre-Processing and Visualization using R. And to present that for us is Mr. Mathias Borketey from Afri-Set department. Mr. Mathias is a research analyst on the Afri-Set project at the Department of Physics, University of Ghana, specializing in air quality assessment, with prior working experience at the Environmental Protection Agency of Ghana, and as an associate consultant at Envirofin Consult. He possesses expertise in air, noise, and water quality monitoring and management. He is currently a master's student in public health at the University of Ghana. Mathias's academic background and practical expertise enable him to make valuable contributions to environmental research and efforts in West and East Africa. Ladies and gentlemen, with a round of applause, let's welcome Mr. Mathias.
Hello, everyone. Good morning. So this morning, we are starting with the computational tools, one of the computational tools. And before we zoom into that, I'll take you through just short presentation on data pre-processing. Then we can zoom into some visualization. Just a brief introduction to data. It's just some information or information collected from sensors from different aspects of some machine. So you have a machine that gives you some information or gives you some things that you would use for whatever means or whatever meaning I want to derive from any that particular machine. So in the field of air quality, we usually look at it as a measurement of information and information collected to assess air quality, right? So if you are looking at data, when you have air quality, then it means you are looking at the information you have collected or gathered from and a device that will give you meaning on the pollution level or the quality of air at wherever you've installed it. So when you look at the pollutant concentrations, it's an example of data you can get from air quality data. We have PM1, we have PM2.5, different aspects of PM. We have PM4 and different ones. We have also meteorological data. We have temperature, relative humidity, wind speed, wind direction. We have emission sources also as another sort of data you can get from air quality. And you have from natural sources, you have industrial, biomass, amongst many others. And then also health data. So you can also get some health data, and then you can merge that with air quality data to do some analysis. So there are sources of data. So we have from monitors, we have from databases, we have from satellite products. And then you can also access this data from different means, from SD cards. Some centers have SD cards. You can get them from there. You can also access some of the data from serial connection. So you take directly from the sensor. Yesterday, some of those who went to the Afri-Set facility saw that there are some sensors that you have to connect them directly to a computer before you can access the data. You also have some sensors or some machines with dashboards that you can directly get your data from there. So you have the sensor that has been connected in a way that there's a dashboard where when you log onto that particular dashboard, you can get all the information you want on that particular sensor. And also there are mobile apps. So we have some of the sensors that have mobile applications. So you have them on your phones and you can just check whatever pollution level or whatever aspect you want to check on the particular sensor. And for data, we have types, file types. So you have some in TXT. So when you're downloading this data from any of these sources and the retrieval platforms, you have types. We have some in TXT, that's the text files. We have CSV, we have Excel, we have NetCDF from most of the satellite retrieval. We have XML, and then we have JSON. So in data pre-processing, it's one of the main steps in data analysis. I mean, in all aspects of, it's not only air quality, but if you are working with data, the first thing you have to do is to ensure that you do all the data pre-processing. You spend most of your time to do data pre-processing, because it's like if you put whatever data I have, you put it into any analysis, you get that results from that data. So if you are not cleaning the data, if you are not transforming the data into a usable format, whatever you are going to put, like they say, garbage in, garbage out. So you put in that particular data, and then whatever is going to be the output might give you some wrong information. So it's important to consider data pre-processing as a very prudent step in data analysis. And you usually combine it with importing of the data first, and then you have to do data cleaning, you do data transformation, and you do feature engineering as part of this pre-processing aspect. And the importance of these is to improve the data quality and also consistency. Ensure that whatever you have in there is very consistent and will help you in whatever analysis you want to do. It also facilitates data integration. You have data from different platforms and you want to put them together as a unique data frame. You have to make sure you do the cleaning well, and that will help you to put these data together. Otherwise, you have some with different formats. If you if you try merging them, you'll find so many errors in whatever code or whatever tool you are using. And also enhance better decision making, because if you clean the data and you put it into any data analysis platform, you do whatever analysis you want to do, you come out with good results that you can use for decision making. So these are just a simple step. So as I mentioned earlier, you have a disorganized data frame or data set from any platform you get it from, and then you go through the process of importing, transforming it, cleaning it to get a very clean data. So you can see a very disorganized queues. You use this machine learning or these tools to transform the data into a very arranged and very usable form. This, you can tell that you have all blue, all green on top, all yellow down, all in the middle, and all red down. Here, it's not like that. It's very mixed. So the data cleaning processing is very important in any data analysis. So if you are importing data, one thing you have to know is either you are importing a single file or you are importing multiple files. Some sensors, usually, they have the files coming daily or maybe hourly or even by minute. So you have a folder created. So we have something like Paperware. With Paperware sensors, you have the file coming in just one for every day, every hour or so. So you have to merge all these files into one unique file, and then you use that to do whatever data analysis you want to do. So if you don't have that skill to merge them, it means that you're going to take one file. In a day, you might have about, let's say, 60 files. You are going to do that individually, and that will be very tedious. So you have to know how to do the data import, whether you're importing just one single file or importing multiple files together. And in doing so, you have to ensure that you check the duplicates of the file. So some files come in duplicates. So you have to make sure that you check the duplicates of the file before you do the import. You also check the data format, right? Every data has a format, as I mentioned earlier. You have some in XML, you have JSON, you have CSV, amongst many others. You have to check the format before you do. And also some data comes with names, right? Every column has a name. And these names sometimes are not friendly to some of the softwares. So before you can even import it into any software, you have to ensure that you check the names, if there are spaces, if there are some special characters that that particular software you're using is not friendly to that. Then you have to change that. You have to clean that particular data frame before you import it using the software to do the analysis. So also on the data pre-processing, one of the things you also have to check is the uniformity across the data format. So most air quality data, right, from sensors or from reference monitors, they all have date, because you are taking a continuous data, a time series data, so they all have date. And the columns will come in with whether PM 2.5, PM10, gases and other things. So you have to ensure that all the data, all the columns have the right format. All right, so date has to be date time. You have the pollution, so you have PM25, PM10. They have to be in numeric, right? You have some other things. Supposing there's a season as part of the columns, it has to be character or something. So if you have all these things in check, when you are doing your analysis, it's very simple. Otherwise, you'll find several errors in that. And also, you have to ensure you drop irrelevant features. So some of the data you download from the sensors come with different features that might not be useful to your work. So you'd have to ensure that you trim those parts out so that when you are doing the analysis, you'll not have different features or different columns in your data frame that will affect your analysis, or it will make the data file too bulky for you to select whatever column or row you want to do. And also, you have to retain the variables of interest, certainly. So if you are deleting the ones that are not of interest, then you have to retain the other ones. So you check missing values, right? Some are reported as NAs. Some also are reported as 999. So some sensors report missing values. If there is no, the sensor didn't give data at that point, it records the value as some will do 9,999. Some also just do 999. Some will even do -1. So you should know the particular sensor you're working with. Some of these things in the structure of the sensor data, so you can take those things out. If you don't do that, you have a 999 data value in your sensor, and it will tell you that that's a high pollution at some point, but that's not the issue. That's just the way the sensor is telling you that it's ended. There's no value there, or the sensor couldn't give data at that point. So you have to ensure that you take all those things out. And also, to some extent, and some if you are doing some analysis, you don't need NAs. There shouldn't be missing values. In those aspects, you have to replace them with the mean. You can replace them with the median. And also, especially with gases, what you have to do is that you have to check the limit of detection. So they have a limit of detection for all the gases. So you see values falling below those limit of detection. You have to ensure that there's a formula that you convert those limit of detection values to replace those NAs, so that you have complete data set for this, the further analysis you want to do. Also, with the pre-processing, one aspect is also handling of extreme values or outliers. And in air quality data, it's very common. And if you don't take time, you end up truncating some part or some important aspect of your data. So you have to ensure that to check the data. Well, most of the air quality data, they are skewed to one side, right? They are not uniformly distributed. So you have to ensure that whatever data you are going to take out, or whatever outlier you are going to take out, is clearly an outlier and not just maybe a value that something that happened at some point. So that's one of the things. So you have to identify and address the zeros, the minimum and maximum values. That could also tell you what's the outlier. So you have a summary of your data. You have maybe your third quartile to be, say, 35, and you have your maximum to be 1,000. Then you have to go and check what happened and you got that 1,000. And in the computational process, I'll take you through how to do those things. So you have to check. So there are different ways to check on the outliers. Some will use the Chebyshev, which is for normally distributed data, or for non-normally distributed, an empirical rule also for the normally distributed. And also on data transformation engineering, you have maybe minutes data. You want to transform it to hourly. You can transform it to daily. You can transform it to monthly. So you can have averages to say, okay, this is the daily averages, or this is the monthly averages, or this is the annual averages. So it's also another aspect of the data pre-processing that helps you to transform your data into a very usable or meaningful form. Yeah, so this will end the presentation, and we always acknowledge our partners we've been working with over the years: AQSpec from US, EPARIF, Columbia University, NILO, and then EPA Ghana. So the next step will be on the hands-on training. So before we start, is there any question?
initially, I want to know how or which of them are available for download without a cost. I mean the commercial ones and then the non-commercial ones, and how to access them.
Okay, thank you. So with the sources of data, we have one of the open ones. We have OpenAQ. I'm sure, I don't know if you are privy to that, but OpenAQ is a platform where you can download most of the sensor data. They have sensors installed across the world. So you can download data from these sensors. One of the issues with data, which most of the people in the quality space have been trying to resolve, is how to get access to data. Because most of the data, most of the sensors installed are from projects. So you have them install the monitor. Now they keep the data. They have to use it to whatever they want to do, use it for, before they can even make it open. So most of the ones on even OpenAQ as sensors or data that people have used it for, whatever project they have to use it for, and then they have to put it on OpenAQ. Previously, we had the US Embassy. It also has data on PM215 and PM10 for Ghana, and then also for other parts of the world, it has some gases. But during Trump's administration, we don't have access to that. So if you want to access data, there is satellite data. That's one. That's the easiest one you can get access to. So we have for PMs, you have Mera2, you can get access to. We have Modis, there are different ones that you can have access. You can download them without any fee. So for that one, it's available. But for the sensor-based ones or the reference monitors, you would have to reach out to the partner or the one who has installed those sensors before you can get access to them. So those are mainly proprietary for personal people who are conducting some project or research. For meteorological data in Ghana, for example, you have to reach out to the GMET, and it's not open. So you have to make some commitment, I believe, and then you get access to the meteorological data. Yeah.
Okay. My question is, thank you so much for the insightful presentation. My question is in regards to the data sampling in the previous slide. I don't need to go about it. My question is, with all the sensors being stored within the Accra enclaves, the data that is being taken that you were talking about and then yesterday was mentioned, is it that the data are corrected? Are they corrected data or the raw data which need to be calibrated?
Okay.
Or so do you have to collect the data from them and then calibrate it in your system, or you have already developed an algorithm that does that automated from the sensors wherever they are located?
Okay, thank you. So for the sensors data you see streaming online, there are sensors that the manufacturers say they have it corrected. So they are the data that is coming to you, that is visible to you, is correct from the manufacturer. But it's one of the reasons why we have Afri-Set, right? Because we believe that these manufacturers, certainly before if I have developed my sensor and then I want to put the data out, they have to ensure that the data that is coming out is good. So I'll try and do some correction. But we believe that wherever these sensors are manufactured, they have different environmental factors or meteorological factors, right, and sources of pollution as compared to what we experience here. So if they correct the data with that particular data they have from their end, and then you are using that data here, to some extent there is some bias, right? So we still consider the data being churned out from these sensors as raw, because in our context it's raw. Because we have different conditions, right? So for Afri-Set, what we are trying to do is we have these correction models for all the sensors that we have evaluated. And then on our platform, we are building a portal where you can put in your sensor data, and then the algorithm will transform it into a corrected data for you, and then you can use it for whatever work you want to use it for. Yes, but for now, whatever data that is coming out from the sensors that has been installed across the country, in our context, is raw data.
All right, thank you, Mathias, for the presentation. So, concern had to do with, in terms of when you have a situation wherein the sensors tend to produce inconsistent readings, what validation method you think would be best used?
Thank you. So with sensor data giving you inconsistent data, first, if you have a reference monitor, then the first thing you have to do is to do a co-location. Right, so you have to take that particular sensor and then put it near a reference monitor because you believe that the reference monitor goes through a rigorous servicing and maintenance procedures. Right, so it's giving you good data. So you have to do co-location first with that particular that sensor with a reference monitor, and then you do some analysis to ensure if the inconsistencies from the device or it's something that is actually happening. The other thing is if you don't have a reference monitor, another thing you could do is to put that particular sensor with the same type. So if it's like you have sensor A, a sensor type A, you have the same sensor type A somewhere, you can put them together, right? Co-locate the two, and then look at the readings from them. It's believed that if they are the manufacturer produced them from the same batch, or I have that same device produced within some particular phase, they should give the same results. So when you put those two devices together and you look at the data and you are seeing some inconsistent with one, then it means that that particular sensor has an issue, and then you have to reach out to the manufacturer. And if they have to do something with that, they will do. Maybe some would want to replace or they recall it. So for those online, we are putting the link in the chat so you can download it and then follow through. So I believe, so yesterday and even before the beginning of the program, we shared some information that everyone should try and then have the R Studio and R downloaded so we could use that as one of the computational tools for this workshop. So I believe everyone has. Please, I hope everyone has the R Studio and R installed, and you have the data as well. And there's also an R script. Because of our time, I dropped an R script in the WhatsApp group. You could also download and open. It's the same thing I'm going to run us through. Please, if you've not installed or you've not been able to install, kindly raise up your hand so our team would assist you do that. I believe we can start in the next 5 minutes. I'm sure by then everyone has the R Studio, R, and then the script opened. So we could run through that. I've reshared the Excel link on the WhatsApp group again, those who just joined, so you could download that. So you should download two files, one Excel file and then one R script. So it has a .r. It's Afri-Set training .r. I believe we can start. Okay, so we asked you to download several softwares. And one of them is R, and then another one is R Studio. So the R is actually the software. The R is the statistical software or the programming language you're using. And the R Studio, it's embedded onto the R. So it's like an IDE, Right? It gives you a very good interface to interact with the R. So you can write your codes, you can save them. And if you open just R, it will give you a very... Well, you can do your codes in there, but at times it's not friendly. So we usually download the R so that we can do our coding, editing, and everything in the R Studio. So that's how we asked you to download the R Studio, which we are going to use now. So first thing, for R Studio or in R, there's something we call package. So the package it's like a toolbox for every function you want to run. So if I want to run several functions, so I want to do several things, there's a particular toolbox I have to call in. I should have that toolbox, and then I open the toolbox, and then I can take whatever tools I need in there, and I use it for whatever work I want to do. So you have to install a particular package to perform a particular function, right? So you would see that I have install packages, and then another install package. So there's a way you can just install one package, and there's a way you can install several. So if you don't want to do them one, like there's a way you can run all together, and you should have internet so that you can run, and it will download all the packages. So that's the first thing. Also, before you work in R, there should be your desk, which is a working directory. So you should have a working desk where everything you are doing will go, there will be on it. So if you want this, you can just take it. If you want this, you can just take it. So there's a set WD, which is setting your working directory, and also get WD to get the working directory. So maybe you don't know the working directory you are working in. You can use the get WD, but before you start, you have to set the working directory. So the file you have the Excel file you have downloaded, if it's on your desktop, it means that you can use the desktop as your working directory. If it's in your download, you can use that. Or if you want to create a folder and put that Excel file in it, so that whatever you are going to do, if you are going to generate any plot and then you want to save them on your computer, if you set that working directory, everything you're going to download would go into that working directory, and it will be easy for you to get access to it. So you can create a folder on your desktop, and then you put the file, the Excel file, and then the R script in it, and that's fine. We can take it from there. So the set WD, you have your file path. So you just have to go. You can go through here, your files. There's a code for that, but there's also buttons you can click to that. So, but please, I hope everyone has the Afri-Set _training.r. Yeah, so I'm going through that code. So you follow, and then whatever code I run, you run, and then you get the same output. Right. So you can just go to the 3 dots if you want to set your directory. So let me close it. So there's a 3 dots at the right side. You can just click on it, and then if wherever your file or the folder is, you just select it. So if I'm going to use maybe this, I can select and open it, and I'll see all the files here. So you go to the 3 dots. If you have created a folder and you have the Excel file in it, you just go to the 3 dots at this side. I'm sure you can see the cursor. Please, if you can't see, let me know so that I would. And then you select whatever folder you created to get your project in there, or whatever you download to go in there, you select it. So, for example, I'm selecting this as my project, and I open it. So if I open, everything in that particular folder will appear on the bottom right corner. So it's an R Studio. So it's a R script. So you have to use the R Studio to open it. So you choose R Studio if you have that downloaded. You will see that in the list of apps, and then you can use that. You can select that, and it will open the script. So if you've been able to open that, and then you have where your files are, you'll see on your computer, you see trial data, and you see the Afri-Set _training. .r there. I have different things there. So if you have created a folder on your desktop as Afri-Set folder, I don't know what name. Yes, so you just open, you go to the three dots, open that particular folder. So you select the folder, right, and then do open. You do open, and it will open the files in that particular folder here. You have it. And you should also see the folder also written here. If you open it, wherever you open it, you should see the path also on the console, on top of the console. If you are not seeing it, so the next step will be clicking on a certain icon there. This one. And then you select set as working directory. So you are setting that particular folder as your working directory so that whatever we are going to do, if there's any output file, it will be saved in that particular folder for you. So we go to the setting icon, you click on the setting icon. So we are setting the folder you have created as the working directory so that whatever you do will go in there, if there's any output. Yeah, so you go to the setting icon, you click on it and you did, okay, that's fine. I believe we all have our work directory set. Okay. So if you are connected to, we have internet access here, so you can run. You put the cursor on any part of, I think it's line 6, and you press Control Enter, or you can just click on Run. So if you click on Run, it will ask you to install, and then you just click Yes, and it will do all the installation for you. Yeah. So on line 6, so those who are prior knowledge could just run the installation so you have all the packages installed. And also if you have R already and then maybe you've used that for some work or some intro thing, if you open the script, the R script I gave you, it would list, because I have some functions in there, it will list on top of it that there are some packages you have to install. So for that one, those who have the R already and then they've been using it for some work, you see it and then you just click on install. But if you are just running that or you are just installing and you are doing it, you will not face that challenge. So you just have to run the install packages, and then when we are done, we can continue from there. So you can run both the line 6 and line 7. And I believe as by now we all have the packages installed. So the packages are installing a toolbox we'll be using in the process. So at every point, if we need a particular toolbox, we'll call it. And I mentioned that you need a toolbox and you have to open it so you can pick the tools you need in there for whatever work you have to do. So the install packages will get you the toolbox. Then library will open the toolbox for you so you can use it. So you have library and you put that particular toolbox that has those tools you want to use. So you have, for example, tidyverse, and we have read Excel. These are tools that we'll use in the subsequent code. So we would have to call them by using the library. So you open the toolbox by running library tidyverse, and then you run library read Excel. So the read Excel will help you to import your Excel files. Because you have an Excel file, it would help you to import your Excel data into R. The way Excel also has a way for data wrangling, so you can do some data wrangling, then some changes to your data. And it's what we'll be using in the next step. So you can run, if you have your packages installed, you can run library. And if it has been installed, you will not get any error. So because I have it already installed, if I run, I'll just have library, tidyverse. If I run the second one with library with Excel, there wouldn't be any error. So you put the cursor at any part of on that particular line, and you can click on run, or you can use Control Enter. You press with Control and Enter to run it. And all this, you can do it here in the console. But usually when you are done saving the file, if you are not really good with the R, you would end up not even seeing where you saved the file, because you have some R data, and if you can't find it or you can't use it, then whatever you've done will become not useful to you again. So we have to use the editor, where you can open a script, and then we save whatever we have as R. So that's why I saved the R script, and I've shared it with you. So anytime you open the R script, it will open in the editor, and then you can do whatever editing you want to do that. If I run here, if I run something here, I can edit it. I'd have to run a different line. Right? But if I run it in the editor, then I can just go and then change it and then rerun it again, and it will give me the actual thing. So if you've been able to run the library and tidyverse, the library for tidyverse and then read Excel, it means you have the toolbox open, and you can call in whatever tool or function you want to use. Then we have the RM, that's remove. Right, so if you have a data in your global environment, and then you want to remove that data from your file, the file list here, your environment is empty currently. But if you import something and you want to take it out, you can use a RM or the second one. The second one will clear everything. But the first one will just clear the particular file or particular data I want to take out of your environment. So you run that RM and then the name of the data in the environment to clear. If you have anything here, anything in the environment that you want to clear, you will use the RM and the name of the data to clear that. But if you have a lot of data in that particular environment and you want to clear all at once, you use the second one, and it will take everything out from there. Then the next step will be calling in the data. There are several ways. You can use import here. If you check here, there is something like a spreadsheet. You can click on it, and then you can read from base, read R for CSV files. You can read Excel, SPSS, SAS data, and Stata data. So if you have that, you can read from there. Also, if you have it in your files, you can call the data also from here. So you can click on the data, and then it will ask you whether to view or to import. So you can also select import data, and it will import it. And it's the same thing we have here. So the code, so if I click on trial data, I do import, it opens and it will tell me read Excel, trial data, the Excel file, right? And I can import it from there. And it's the same thing I have here. So I want to name the data set, one of the data set Afri-Set, right? And then I call the data as trial data. So this is when you can use it for CSV. Usually CSV you can't have like different sheets in one CSV file. So CSV has just the particular file or the particular data you want to use. for Excel, you can create different sheets in that. So the second one, you would see I have read Excel. And then I call the name of the data, which is trial data. And then I put the name of the sheet. So if you check the Excel file, there are two sheets in there, right? There's pollutants and then there's weather. So I want to call both. So I'm calling the first one Afri-Set. So I'm running line 21 instead of 20. 20, if you run it by default, it chooses sheet 1, the first sheet. But because we have several sheets, we have two sheets in there, in that particular Excel workbook. I want to select the first one. And I have to choose, if I call the data, and I'll choose the name of the sheet, so which is pollutant, as you have in the Excel file. Then I run it. I should have Afri-Set in the environment. So you run the 21, line 21, you have, yes, anywhere in the line 21. You just control enter, or you click on the run, and then it should load your data. Afri-Set, so you should see it here. Then we'll be calling the second data, which is weather. Yeah? Yeah, so if you run it, for you to see, it has to be in the environment. So that's why. So when you call it, it will be there. That's where you can use it. If it's not there, you can't use it for any work in the editor. So you have to make sure you run it to have it in the environment. Then you can run the second file, second sheet, or the second line, which will give you the second sheet as weather. So I have Afri-Set 1 as the weather data. So the next 25, 26, 27, they are just to check your data set, right? The names will give you all the names, or the column names for that particular data set. So if you run names, you should see, so Afri-Set 1 is supposed to have weather parameters. So if you check, if you run it, you should see date, precipitation, WS as wind speed, WD as wind direction, temperature, relative humidity, and pressure. If you run line 25, you can change the Afri-Set to Afri-Set 1 to Afri-Set and run. You have the columns in that particular file as well. So device ID, date, PM2.5, AQI, PM10, and NO2. Please, how many of you are here? Okay. Okay, so if you have the Afri-Set and Afri-Set 1 in your environment, you can use the names to just get the names of the columns, the view to view your data set. It's just like clicking here to see whatever you have in your editor. So, and then the structure, STR, gives you the formatting. So if I have, it tells me the date formats, the other columns I have, what are the formats. So I could also use that to check if all my columns are in the right format. If some is there that needs to be a character, but then it's a number, I have to convert it. If the date is not in the right format, then I have to also convert it. But as you see here, we have everything in the right format, so we'll go ahead. The next line is converting date, the date format. But our date, the data we have has the date format right, so we don't have to change it. But in case you have any data set from any sensor that has a date format which is not in the POSIT, then you would have to use this line of code to convert it from whatever format it is. If it's character or if it's even in numbers or date, you can then convert it to the right format that we can use for some other packages to be using the other sessions coming up. And also with the Afri-Set, there's a column we call device name. Most sensors, when you download, maybe I'm downloading a citywide data set. So if I download, we have all the cities just in one file. So we have a particular column that you can filter, and then you select which city you want. Maybe some ID, so maybe this ID tells me it's this particular city, this ID tells me this particular city. So when you run the unique, you get unique with the $ to select whatever column you want to see the unique IDs there. So it tells you that in the data set, Afri-Set, we have several sensors. So so about 13 sensors in there. Right, so 13 sensors, and it's downloaded onto just one file. So if you have to do any analysis, you have to make sure you filter whatever city or whatever device you want to use for that particular analysis. If you put all together and do it, you might get results that will not be the true meaning of what you are doing. So you have to, some sensors come like that. Some sensors you can just download for a particular city individually. Right, but if you have it like this, it's also easy because I can just, from the line of code, just filter whatever city or whatever sensor ID I want, and I use it for whatever work I want to use it for. Right. So that's what the unique will do, to get the unique ID of that particular column. So it's because it's device ID, it could be cities, and then they have different cities, right, and the other parameters. So you just, the unique ID will tell you the different IDs. Now, the next line from line 38 is we are trying to filter a particular sensor, and then we work with it. So we are saying we want to give the sensor the name Accra, that particular sensor name Accra. And you see this, the function, the percentage greater than a percentage, it's called a pipe function, right? It's a pipe function. So we use that to transfer. So you tell the code that when you take Afri-Set, then you pipe it to do to the next step. So we have Afri-Set, pipe to filter. So it will take the data Afri-Set, then you to connect it to a function that is filter. And then the filter will now take whatever device ID you want. So we are saying that we are selecting this device ID from the list of device ID we have. So there are several IDs, but we are saying, okay, let's select this ID because that's what represents Accra, or that's what is installed in Accra. This is for the purposes of what we are doing. All right, so Accra, we name it Accra, then we call the data set, which is Afri-Set. We pipe it to the filter to select the device ID. In R, if you want to do, you have to use double equal to. If you use one, it will not work because really these are different things. So device ID is equal to this number. And you are saying that it should ensure that the PM 2.5 column, there shouldn't be any. So you shouldn't select anything that does not have, that has any. If there's any, it shouldn't select it. So it considers the device ID column and also considers the PM 2.5 column. So if there's any NA in that particular PM 2.5 column or there's no data there, it will not select it as part of what you're doing. you can clear it, and then you run with just a filter, device ID, and you get your data set. But there might be some NAs in there. But because you don't want to work with NAs, you just tell the device that don't select any NA in the PM2.5 column. Then you pipe it again, right? When you pipe it, you tell it to now select the columns of interest. So now there is 2 device ID as part of the name of columns in the data set. So I'm going to select without device ID. So I could just do minus device ID or select the columns I want. So I want PM2 date, PM2.5, PM10 AQI. There's also NO2 in there. If I go up a bit, I think. Yes, there's NO2 also there. But I'm selecting only these 4. Right. So I tell the function to select only these 4. And also intend to rename them. So you now pipe it to another function. Okay, after doing the selection, rename it. So I rename date as date, the same thing. But the PM2.5, I want to call it Accra PM2.5 because I'm labeling the name of that sensor I'm selecting to be Accra. So I say name the PM2.5 column as Accra PM2.5, PM10 as Accra PM10, and then AQI as Accra AQI. So if I run any part in the line, if I put the cursor there and I run Control Enter, I should have Accra. And if I open it, you'll see that they have date, Accra PM2.5, PM10, Accra PM10, and then Accra AQI. Please, I hope you are all good. I'm too fast. Okay. Yeah, so you can do most of the things, the basic stuff in Excel, actually, but then you would have to filter. But this one with just a code, it will just give you everything you want. You just put all together and then you run it. So you just have your data sets now out with all the renaming and other things. In Excel, supposing you have the different, you have to filter maybe everything. You select this particular column, I change it to what I want. I go to this also column, I select it. Then when I'm done, I have to maybe copy all to different sheets or something. And then now I'm going to do renaming. You get it. So Excel can do it, but to some extent, when you have this done, it's just about 4 lines of code. And then it will do that for if you have different data sets. You get it. So supposing you have, like I have 13 sensors, you have to be doing that individually from Excel, and it will be a bit tedious. So that's why we moved to this one. Yeah, but Excel is also fine. Just that there are some computations that it's a bit tedious to do in Excel, right? Even though you can do it, or even some of the plots. Yes, but this one can do it very simple for you and easy. Please, any question? Our time is almost up. So if you have Accra there, you can run the next line. It's the same thing, but I just change from Accra to Kumasi and selecting a different sensor ID. So you see there's different sensor IDs. So if you run Kumasi, you should have Kumasi also in your environment. I mean, if you want to do editing, maybe later in the when we are done with today's session, you can sit down and then do some editing. You can select different sensors and work with them. But because of time, we'll just go with what I have generated so that we can. So after running the Kumasi, if you have the Kumasi run, we can. So the next line 50, is just a summary. It gives you descriptive summary of the data set or the column. So if I just run for Accra, it will give me the minimum, maximum, first quartile, second quartile. There's also another library called FSA that will give you different descriptive statistics. So that one comes with mean, median. It gives you standard deviation. So it gives you the count of data. It gives you the mean, the standard deviation, median, first quartile, third quartile, and then the maximum. And yeah, I also mentioned about duplicates. So this data set we are using, we are expecting that all the values should be unique. And most especially if you have about 4 decimal places. So that's one thing you also have to take note in your data sets. The duplicate. So some census don't even have decimal places. So they are just whole numbers. In that aspect, if you want to remove duplicates or you want to deal with duplicates, if you don't take time, you take all the data out of your data frame. So for such census, you have to be very mindful how to remove duplicates from them. But if you have census with, say, 4 decimal places, you are sure that even with the last decimal place, it wouldn't be the same continuously for somebody. So if it's the same for, let's say, 5 times or even 2 times, then you have to check that line. Was there anything or did something happen during that period? Right. So it's one aspect of data pre-processing where you have to ensure that there are no duplicates in your data set. Right. So this line of code we are creating a name called Accra U, like unique Accra, and then we now call Accra group by the column we want to check the duplicates with. Then we summarize by count, and then we filter all the counts that are greater than 1. So if it is greater than 1, it means that there's some duplicate somewhere, right? So you could then check which. So if I run Accra U, it will come in my environment. If I open it, you see there are some data sets that we have several counts. Like you have some occurring 2 times, some also occurring 3 times, 4 times. So for a quick check, you can just take any of them, any of the values, right? You can just take any of them. Say we are taking 4.55. We see that one occurred most. So 4.55, we can just check 4.55. Sorry. 4.5. So this hourly data, you could see it runs through. It's the same thing for PM 2.5, PM 10, and the dates are also the same. Sorry. You see the dates are the same. So the first and second, 15th and 15th. And the values are the same. So this is likely a duplicate in your data set. You see also 18th as at 4 p.m. The same value running through. That should also flag a duplicate in your data set. But as I said, for 1 decimal place, even with 2 or no decimal place, you have to be very mindful before you remove duplicates. Otherwise, so you would want to remove duplicates when the data are the same. Then it means that when the sensor was giving out the data set, maybe there was some duplication in transmitting the data. So that's why you see 2 dates. Another thing that could happen with you getting 2 dates is maybe you have data in minutes, and then you are converting it to hour. But with the date time, you didn't include, when you're converting the date, you didn't add the second aspect, or the minute aspect, you just did to hour. So it would have that aspect, the minute and seconds aspect truncated. So you'll be getting, say it's maybe 12:05, the next one is 12:10. But because you didn't add it in your date conversion, it will put 00, and then that will show duplicate, right? Which is not supposed to be, and it's because you didn't do your data conversion well, your date conversion well. So you also have to ensure that when you are doing your the date conversion that we passed earlier, if you are doing the conversion, ensure you have all the hour, you have your minutes, and you have your seconds in there, so that whatever is going to churn out would be unique, rather than having something that could worry your data set. But for these ones, they are duplicates because the data came in hour. So you can also run which to get the row that has the duplicate. And this is also another way to find duplicates, or you want to find outliers, right? So if I run row which max, so I want to see the maximum value in my data set. So I'm saying that which row has the maximum value in Accra data PM 2.5. So if I run the row and I tell the code that take Accra, that row that I did, add +5 on top of it, and then +5 at the bottom. So you have your maximum value and have the 5 data points that preceded it and then the 5 data points that succeeded it. That could also tell you whether they are duplicates or they are even outliers. So if I run so the maximum here is 465. And you look at the data preceding and the data succeeding. In outlier detection or even duplicates, if there is a trend going down or going up, then that is not an issue. But supposing the 5 or the values that preceded or succeeded that particular maximum value you have, maybe there's a sharp jump. Supposing it's 400, the one that came before that was maybe 30. Then it's questionable. How come the pollution level jumped from 30 all the way to 400? I mean, it wouldn't happen. There should be some transition. It should be rising. Whatever is happening, then there should be increasing from one point to the other before you get to that particular high value or that number you're looking at. So if you have a value as maximum, and then with that maximum value, you look at the numbers, the values that come before and the values that comes after, and those values are in transition, then that particular maximum is not likely to be an outlier. But if there's a sharp jump, that I see that there's a sharp from 400, then the next line was maybe 30, and then 30, 31, it continues like that. It means at that particular point when the sensor was transmitting data, something happened, or there's been some fault or miscommunication on the side of the sensor, which then means that you have to remove that data. Otherwise, it will skew your results and affect whatever analysis you want to run with that. And yes, was. You can do as many as you can. So these are values you can edit. So I can do 10 here and 5 here. I can do 15. Any number you want to see the numbers preceding or numbers succeeding. It's about kind of solution. No. So what you are doing first is to check the row or your maximum value. Right? Maybe you want to see if that value in there is an outlier before you take it out of your data set. So you check the value. And then when you check the row of the value and the value itself, you do a slice. So you tell the function to, okay, I want to see the 5 or 10 the values that came before that particular maximum and the 10 or 5 that came after. So it prints those values with that maximum value in there. So I could look at that and then tell whether that value is a possible outlier or not. Yes.
Okay. Thank you.
So because you have duplicates in there, as I mentioned, with the code I ran earlier with the dates duplicates, we would want to ensure that all the dates are distinct. So you run this code on line 78 to remove all the duplicate dates in your data sets, and we add the function keep all so that whatever new data set you are creating, if you are giving it a different name, it will not come with only that column. Because if I run distinct Accra PM 2.5, now Accra, which has different columns, would only come with Accra PM 2.5 because I'm not telling the function to keep all the other columns. So this is also important in this line of code. So you have to keep all it tells the code to keep all the other lines. So we'll run that one too. And you have your Accra. If I run any duplicates now, there wouldn't be any duplicates in the code, the data sets again. Then also dealing with outliers, you can decide to, if you find out that there's an outlier, you could run a cap for your data set. So you see that you have a maximum of 500. After 500, you have some value like 2,000 going or 3,000 going. It happens. Some census, at some point, they fail to give you the right results, which start giving you some higher values. So if you look at your data set with whatever line plot or shrunk distribution, then you realize that most of the data follows a trend and ends at maybe 400. And then there's some gap before you start seeing maybe 3,000, 2,000 other data sets. Then you want to put a cap on your data set. So you tell the data maybe between this particular cap, select between this particular cap. So it truncates the aspect of the data that is possible outlier out of the data set. So, and that one uses just a simple conditional sentence. So if else, right? So if else, if Accra is less than or equal to 1, then put NA there. Otherwise, keep Accra. So it goes through your data set. If there's a data set that is less than or equal to 1, it puts NA. If the value is greater than 1, then it will put the Accra data, the value that is there. So if I have 5 and the function reaches that particular line, because the 5 is greater than 1, it will keep 5. But if it's less than 1, it will put NA there to take out that value I consider to be outlier. So supposing I'm capping my data at 500 as well, if I run this code, it tells the data set that any value that is greater than 500, put NA. So I don't want to use that data, so put NA there. Otherwise, keep my rules or my values as they are. So it will go through the data sets row by row, check the values. If it's greater than the 500, it will put NA there so that you can use that value. Then you can do NA omit to clear all the NAs that has been generated out of this codes. Some also want to replace the NAs with, as I mentioned earlier, with mean, with median, or with gases especially. You have to look at the limit of detection, right? And then you use that to replace those NAs. This code also, if you have a correction model and you want to create, so you have a PM 2.5, they're giving you a correction model, simple linear regression model with coefficients of PM 2.5, temperature and relative humidity, or only PM 2.5. You can just use this code. You put your coefficients there, and then you run. It will generate a new column in your data set with the correction. So you have a new column with the correction that you inputted. So this will be like your correction factor. Say it's PM 2.5 has a coefficient of 0.69, and then temperature has a coefficient of negative 0.12, and RH has negative 0.15. Then you have the intercept as 17.51. So you input that with a mutate function, it will create a new column with the corrected values there. So if you have a correction like that, you can just use that to do your correction of the data set. And this line of code at 108, in case you have different data sets, so like we've created Kumasi, we've created Accra, there's also another weather data there. We want to put them together to run analysis on all of that, because in a function you can have this data here, this data here, and you'll be working with the function here. So you have to bring all of the data sets together. If I want to do some analysis between Accra and Kumasi, I have to put them in the same data frame, and then I run the same function so that I would use the way they are being put in that columns. to give you whatever analysis or whatever results that you want. So you can use this function. There are several methods, but you can use this function. It's a reduced function. It's in the tidyverse, but that's why initially we did the tidyverse and then a read Excel. The read Excel for importing, but then the tidyverse will give you access to all these things. If you don't have tidyverse, the functions we've been running, the pipe will not work. Your reduce, the mutate, and other things do not work, as well as deploy arrows. When you come to the next line, 111, the all data, the slash with the greater than sign is also another way of writing the pipe function. So you could write a pipe function using the percentage, greater than percentage, or this way. And you can run it in the way that if you have a data set, I mean, in our environment, we have dry and wet season. So you want to tell the data set, you want to tell the host that when you take my data set, create a month, right? That will be written with this format, January, February, March, in that way. And then using the if-else condition, separate the month. So if the month column is January, February, March, November, December, you put dry, otherwise put wet. So this will give you a different column with months and also with seasons. So you have now your wet season and you have your dry season in your data set to the same data frame. So I could run this and run this, and all data. I should have month here. I have seasons as well. I also embedded latitude and longitude in there. So latitude, I was using Legon latitude and longitude. So you can add that one to your columns. And then if I want to write the data, so the data I've just generated, if I want to write it onto my laptop, I could just use the write Excel library. I run it, and then you just name, if I put all data and I say, okay, name it Afri-Set data. If you check here, it's not here. So if I run, it should come there, right? Now, whatever I've done there, I have it here. So it's now on my laptop, and I can use it for any analysis I want to use it with. So you just call this library, this toolbox, and then the name of your data set, and then however you want to name it, and you run it. Then this will be because you have like 5 minutes. So this one will be the visualization aspect. You are just going to run. So if you have everything up to all data, and you open these libraries, this is an open air packet function, time average. So you can use it to do resampling, daily, monthly, annually. So you just have to change here what you have here, and here you put the name of the data set. So if it's all data, you can put it here, and then we change these. So we have hour, you can change it to minute, you can change it to day, you can change it to month. And then when you run it, will give you the that time average or that resampling data you want. So a very quick one I'm going to run, because if you are able to run all the way to all data here, then you wouldn't have issue running any of these. So these are the visualizations. So you can run a scatter plot. There's the X, and then you have your Y, you have your Z. The Z can be temperature or relative humidity or something you want to see if, based on the correlation of these two data columns you are selecting, at what point that maybe if it's high, if temperature is high, do they correlate to, or if it's low, do they correlate to, or? So usually when you're doing with reference monitor, we tend to see whether the bias from the sensors comes at high temperatures or at high humidity, or low humidity. Right? So if you have reference monitor data, you could just run. So you run this code, you have your scatter plot here, right? And it has scatter plot of PM10 versus PM2.5. You can also run a time series plot. So if you have, as I said, if you have a time, the all data, and you run, it will be easy to run all these things. So you can run for 1, you can run for 2, you can change, there's a ref Y, which is, you can use that as a standard value. So supposing it's PM2.5 data, and in Ghana, for example, the daily average is 35 micrograms per cubic meter. So if you have a daily data, you can put 35 there. If maybe you want to compare between the Ghana standard and also the WHO, you can put the 35 and put 15, and it will give you different lines, like the blue lines you see here. It will give you 2. So supposing I'm doing, the second one will you see there are 2 lines. So I could edit it to give me different lines to show whatever standard I want to portray on the plots. And you can also run a time variation plot. It gives you in time, different times. So you have month, you have hourly averages. It gives you the time of the day. I can expand it so you see. Right, so you can see the hour of the day. So in the morning, yesterday I think there was one presentation to, I think, Dr. Fred, talking about the early morning peaks. Right, so you see the morning peaks, you see the late evening peak as well. And then, I mean, in Africa, certainly January, we have higher pollutions all the way down. These are 6 months data. And it also tells you on each and every other day what happens. So on Monday, how is the peak during the time of the day? On Tuesday, all the way to Sunday. And you get the same averages at the other side too. And we also have a calendar plot. So this could also tell you you can use the AQI, you can use the PM2.5, right, to run all this. And it tells you at which days of the year you have higher pollution levels. So there's a break in the code where you can select based on the AQIs or the PM2.5 values or PM10 values that corresponds to the AQI colors. Because we have wind speed and wind direction data, we can also run a wind rules to tell us the direction of wind, right? So we could have something like this as well to tell you the predominant wind direction during the time of your data collection. And last but one, we also have a polar plot. So it tells you so in this plot, I added a function, we call it conditional probability function plot. And what it does is it tells you, you can put a percentile in there, and that percentile tells the plot will give you that at this percentile, so at the values you are seeing there, or whatever map you're seeing there, are values above 57 micrograms per cubic meter. And it tells you which locations these pollution levels are likely to come from. So you see that usually if they are around the center, they are more localized. If they are far apart, then probably regional. And usually you could also tell from the Hamatan, most of the data, so you see that the high probability will be coming from the northeastern side. So you have those places very red. You can change the CPF to mean. And it will give you the same plot, but this one uses all the data sets. It will not break it into the percentiles. So this is the mean, just the mean. The previous one was based on the CPF plus the conditional probability function plus. And the last one to end this session will be polar map. So the same plot we did can be embedded on the map, right? And you should have some internet. Right, so this is UG. You see Legon, and you can pan it the way to tell you that's pollution map on the map of wherever you are taking the data from. I mean, you can do this for different points, and then you see all on the map the direction and the pollution level from different aspects of, and I have it divided into wet and dry. So you can choose wet, and then you can choose dry. You can divide it into years if the data is in years. If it's a month, you also select from there, and you can download it on your computer. Yeah, so this will end the session. This is the last plot. So if you have the all data set, then you can run all these things, and you wouldn't have any issue. Yeah, so thank you very much.
With the process which they have, is it already embedded? I mean, some of these things are embedded because you could see map which they've made available for you to get hourly, daily, and all that. So with our own, use our own as an example. So how do we, get our data then to start doing all this?
Okay. So with your device, they have a portal. I'm sure you have the portal. If you
have access to the portal.
Yeah, you have access to the portal. So you could download the time average you want. You could select, there are different buckets you could select from. 5 minutes. They have raw, they have 5 minutes, they have hourly. Yeah. So you can select that particular time average, and then you download it, and it will give you only in that sampling time.
Okay, so is it that they've already segregated?
Most portals have them segregated, so you can select hourly, you can select daily, and then whatever data you're going to download will just be in daily averages. But usually we advise that you download the least resolution so that you have a clear idea of how the sensor performed or behaved over the period of installation. Then you can do your averaging yourself. You can do some removal of some outliers, some duplicates, because some of these sensors, they just look at the chunk data coming in. It's been done that, just average it when it comes to this number. So it will just, when it gets this number, it will average it into the average hourly or daily or something. So if you get the raw data, it's better. So you can do your...
So for our raw data, using our own platform, so can we easily access that, or we have to request?
No, you can access it.
You can access
raw, you can access 5 minutes.
You can access what?
Raw, you can access 5 minutes.
5 minutes?
Yeah.
Okay, I'll try it out. Thank you.
Sure.
Thanks very much for the presentation and the everything. I wanted to find out in this scenario, how was data gaps treated? Yes, that's one. And I can see that there are some of us who are not good in the coding aspect on some of these things. Is there any software that, like click, upload, and it will do some of these things for some of us who don't know some of these things for us?
Okay.
And lastly, you know, the range for which some of these data points can be used for the analysis, those out of range. For example, if a data point is 9,900 and something, is there specific analysis that those data points can be used for? Thanks.
Okay. Yeah, so first off, I'll start with the last question. First off, the extreme values are considered to be errors from the side of the sensor. So it's been programmed in a way that if any issue happen, that you see the sensor data is not acceptable, just it's either you push 0 or you put -900 or you put 9,000 or something. So those values are values that are supposed to be for your purpose, unless you are actually studying the device, how it works, or maybe you have developed your device and you want to see if it really gives a continuous data, a good data, then you can take these values and you can tell the number of times your device failed to transmit data, or the number of times the device was unable to do something meaningful, right? But for your analysis on air quality or pollution aspect, then that one, those data sets are supposed to be truncated off. And also for the clickable softwares, yeah, I think there's but more that will be more statistical and not for this sort of maps. Maybe Stata or SPSS or but usually to do some of these things, you would have to write some English. And this is more English. I think with the Jupyter ones too, you have some English in there you write, and then it will take you or give you whatever response that you want. Yeah. And yes. So for data gaps, what we do is that for us, if your data is not giving more than 75%, so that's like the third quartile, then even in our evaluation, we don't consider that data to be fit for evaluation, because it should be enough. You should have enough data to tell the story that your device has to tell. So if you don't have data more than 75%, then we will not accept the data. So we consider that data to be maybe there should be an issue with the data. We have to reach out to the manufacturer. And unless you don't have any sense, you don't have much data from different aspects to use. So for those ones, then you are considering using means. That's when there are some analysis you want to do. You have to use the mean, or you have to use the standard deviation, or some of the considering the LODs of some of the sensors to replace this limit of detection, these gaps. Yeah.
Hello.
Yeah.
So I just wanted to say, follow on from where his first question about people not having the experience with coding, and just to encourage everybody that it's easier than you think. It's much easier than you would imagine, and especially now in the age of AI, you can literally write code in AI by just giving it. For example, if you were to load an Excel file to say ChatGPT or any of them, and you were to describe in detail what you want to do, it would give you. So but you need to have the basics of say R or Python or MATLAB or whatever it is. Generally, the idea is master one of them, and you'll be good to go. You may need a bit of the other every now and then, but the point I want to make is it's easier than it looks difficult when you are seeing it for the first time, but then it's just like writing at all. It's just like writing essays or whatever. It's difficult when you haven't started, but once you start, and there's a whole community on the internet. Almost every error, the way I do it is you get an error, you can copy the whole error, paste it on Google or whatever, just paste it. And somebody has faced that same challenge before, and somebody has solved it for free. Okay, you just copy your error message, paste it in a Google or whatever search, and then you find that same problem, somebody has faced it, and you find hundreds of people commenting and telling them how to fix that problem. So it's much, much easier than you would think, and it makes your life a lot easier to learn some programming. You can see how with just one line you're able to filter your data and so on. Imagine doing that in Excel. It will take you several days, and then you get tired. Your brain gets tired looking at so many numbers, and there will be errors. So it's easier than you think.
Yeah, thank you.
All right, to add to the one Dr. Otulabi said, in programming language, also you have to be a little bit careful, because you can't combine too many programming languages. Yeah, you have to stick to one. So you have to make a decision whether you are married to, you are married to a single lady, or you are going for two. And how to manage the two simultaneously. This will remind you of me. So today you have to decide whether you are going for R or MATLAB or you're going for Python or IDL. So you stick to one, you solve problems, and if you're a beginner, you have to start with a little syntax of how to plot X and Y or how to read the data. If you want to jump into color plotting today, it will take you years, and you'll be complaining. So form a team and start reading the data file, one after the other. You spend time, you get a headache, you cry, you go back to your room, start again. Yeah, there's no easy solution, as Doc has said. So thank you so much.
Yeah, thank you. And one of the community, I think Stack Overflow, it's just now that we have AI, so most people don't visit Stack Overflow, but usually when you put your questions there or you have any error, you put it on Google, you first see Stack Overflow, people giving you like responses on those errors. So yeah, I think that should be all. All right, thank you very much for paying attention. And
welcome back, everyone. I hope we are all refreshed now. So we'll proceed with our next presentation. Our next presentation has the theme Data Retrieval using API, such as OpenAQ and Purple Air. And to present that for us, we have Dr. Cosmos Wemegah from University of Energy and Natural Resources. Dr. Cosmos is a research fellow at the Institute of Earth Observation Research and Innovation and affiliate lecturer at the Department of Atmospheric and Climate Science at the University of Energy and Natural Resources. His research specialties include urban climate and micrometeorology, with a particular focus on urban heat or pollution islands and thermal discomforts, air quality analysis, and extreme weather events. His interdisciplinary work bridges climate and air quality research. And he uses analysis tools such as Python, R, CDO, and remote sensing platforms such as Google Earth Engine, QGIS, and ArcGIS. These technologies enable him to analyze data sets from various sources, including instruments, sensors, satellites, and reanalysis products. Ladies and gentlemen, please put your hands together for Dr. Cosmos Wemegah.
Yeah, it's still morning. Good morning. Yeah. So I think today we've done enough programming and a lot of confusion. So, yeah, and a lot has been said about the programming. There's one thing that I enjoy about programming. In fact, please, don't worry yourself. I know some people are trying to understand what is there. Don't try. So, this one is a true story. You were not there. I was the only one. So, when he was talking about data processing, there was something that struck me. That was when I understood what data processing was. So I didn't know that when you are going for a date or you are going to see someone for the first time, I heard some people even prepare for 2-3 weeks before the day. I only showed up. And when the person saw me, that was another thing. So I realized that was when I understood programming, pre-processing. So you pre-process yourself, put yourself in a very good way, so that as you're on the date, the person is analyzing you to understand you. So when you appear in slippers and shorts and some hoodie, the other part of the analysis goes off. There's nothing to be said again, right? So that was it. So that's how data processing is. You try and clean everything, try and put yourself in a very good shape, in a very good manner, have some nice haircut, and all other things before the time. Then when you get there, that is when you try to look at certain details about the person, right? Rather than looking at the dressing. Okay? So now you have the time to look at other features that are much more important and for you to take critical look at them and then work with. So that is data pre-processing. All right. Now, what we are going to do today, it's still the processing. I think our first presenter was talking about data sources. So he made mention of Open AQ and other places that you can get data. Now, there are some of the platforms that when you visit, you can't interact with the system, even to download the data. The data will be there, but it will be very difficult for you to have direct access to the data or to be able to download them. So what they do is that they have something we call API. Please, who can tell me the full meaning of API? Yes.
So the full meaning of API is Application Programming Interface.
Application Programming Interface. Okay. So there's a certain application. Okay, it uses programming, but it has a certain phase. So for you to be able to interact with that phase, that's having your phase exchange with that phase, that's what we call the interface. Okay, so you interact with that programming to be able to get the data. And it is very good for the servers when they use it that way, rather than you going there to download. Okay, it saves space on their machine and everything on the server. And it also slows down the traffic that sometimes come on their server. So they use these things. But to be able to access them, because they speak Dagbani, when you go to them, you have to speak Dagbani. That is programming language that they understand. So if they are speaking Hausa, you have to go and speak to them in Hausa language. Please, I hope you get it. If you don't get it, please let me see you by hand. This is how I teach my programming. So if you don't get what I said, let me see you by hand. If you don't understand this one, what I will do, you won't understand. So to be able to interact with the system, you have to speak their language. And the language that they speak is Python, the snake. And then R, the one that runs. So you just put it in your head that you can speak with it with the R, the one that we've done already, and then the Python. But they also have their own words that they use. And these are the syntax that you have to use to communicate to the system. Right? But I've been teaching this aspect of the workshop for other trainings and including Afri-Set, I think last year. And I realized that even today, when our first presenter was going through, I could see the faces and how people were struggling with their R. So what I've done over the years is that I've reduced most of my training into some small application that you would be able to get. It is about 80% complete. I'll put it in production volume and then I'll put it on my GitHub page. So for that one, you can just go there, you download, and you use it. It is free. And once you get it, the only thing is just any data that you have, just put it there. Put the data in there, no programming. You click, you select, and it will run for you. So that is the aspect that I have done to make things very simple for everyone to use. So today we won't do much of the thinking and going through all the other things, but I'll have to scare you small. All right? Yes, I have to do that. So I hope you've gotten your API keys. Now, these are the keys, the information that I sent. The keys are certain passwords. Let me put it that way. So it's like literally like a key that when you go to the system, if you don't have your key, it will not allow you to open the door. So, and it will recognize individual keys. So you don't have to be using somebody's key. All right. Otherwise, if you give your key to somebody to go through the same door, you create traffic for your own self. So your own key will be giving you a lot of traffic on the system. So that is how we are going to go about it. So if you have your API key for the open AirKey and then the purple layer, please let me see you by hand. If you have the API. Please, I want to see your hand up like this. All right. Okay. So for the open AQ, right? You will see this. Okay. So when you register, when you register online, okay, yeah. So this is the OpenAQ, their platform. So this is their platform, okay. And then when you go there and you want the data, it is very difficult to get it. So what you do is that you try and log in. So when you click on explore the data, okay, when you try to explore the data, you will see locations where we have the data sets. So this is similar to what Professor Dan showed yesterday. How the coverage is, okay, around the globe. So you just have to log in. So if you go to the top here, if you don't have any login, you just sign up, okay, or you register over there. So okay. So you see this platform. Yep. All right. So you're able to get information on each of the data sets that you want. Okay, there's a small thing here. I don't know why it's not showing. That's extended to that side, but we would manage. So you can get details on the data that you want, and it will show you where the data is located and everything. Okay. So you can click here to download the data, and then you can choose when you want, and then you click on download, and as simple as that. But this one is on the open AirKey, okay? And then the data will be downloaded for you, all right? So when you check on the purple layer 2, okay, those who have downloaded the 2, that is also very simple to use. You also need to get You also need to get an API to be able to work with the two. Okay, so the two, they have a link there, one for Mac and then two for Windows. And the Windows, you have two, one for 32 and then one for 64. So depending on what your machine is, if it's 32-bit, 64, you go for one and then you just install. It's very simple to install. Those on Mac, to be able to install that, unless your security, you permit some things within your securities to be able to do that. Otherwise, it will detect it as a certain malware. All right. So, when you look here, the API key, okay, so it will give you an instruction as to how you can get this. Once you register and you go on the page, you will see the keys there that will be open for you. And then you can just copy it, all right? And then I gave a certain file. I've forgotten how I named the file. How did I name it? I said it's a text file, but you can copy it. So just copy the information in there and then paste it inside an R, okay, for it to work. It's probably open. It's open AQ. Okay, so check the WhatsApp group there, something like that. Open AQ. Yes, open AQ.txt. Okay, so when you open it, just copy the information there, open your R, and then paste it inside there. All right, that is all. That's all that you can do. Or you can also open it, go to save as, okay, you go to edit or something file or so, you click save as, and then you save it, but with .r, okay, all files, and then you just save it as .r. All right, so inside that information, you will see something like this. You will see something like this in there. Okay, so this is similar to the key that you, so this is my OpenAQ 2, the key. I think today everything is working against me, so it's fine. Yeah, this is R. Please, yes. If you are confused, the other side of it, we are not doing what you did in the morning. Okay? So if you want to do anything, when you open your R, you can please come here. This side. Have you seen this green here? It will allow you to add a new file. Okay? So you can just click this, and then you click on this one, R script. This will open a new file. Then that one that I gave you, you can just copy and paste. Okay. So when you click on this like this, you can just copy the code in that file, the openaq.txt, and then you can just paste it here. All right. So this is what I was talking about, the openaq.txt. So this information here, you can just do Control A to select all of them, and then Control C to copy. You can just come here and then you paste. As simple as that. I'm sure copy and paste is no programming. So this one should be very simple. Now, when you get this, I've made it in such a way that once you're able to get your key, this side, you just put your key in there, here. So that section where we have the paste your API key, this one is for open AQ. You just put your key inside there, you paste it there, and then you start running it, all right? When you run and you don't have all these installed already, you can just go to packages. If you want to install any package or any library that is missing inside your R, you can just go to packages here. At this point, click on packages, and then you go to install. Once you click on install, the name of that package, you can type it there. Okay? And sometimes they will start appearing. So you select. If you want to install multiple, you just make space. Okay? And then you type the next, space, then you type the next. All right? So that's very simple. And then you click on install. It will install all the dependencies for you as well. Okay. So this is part of what I did last year. All right? This is part of what I did last year. So the only thing is that in programming, there are certain packages that help you to do things very easy. It is similar to when you are traveling. Okay, just as you were traveling to Ghana or you are traveling to Accra, you open or you picked a certain bag, you went in for your toothbrush, your sponge, your towel, your soap, you put in some shoes, some clothes. Those are the things that you will need when you come here. Okay, so those are the packages that you have to work with when you are doing R or Python. So in Python, we call them packages. Mostly in R, we call them libraries. They are the same thing. Okay, they help you to do things very, very easy. All right. Other than that, you have to, when you come here, you have to go out and go and buy the things that you already have. Okay, so it's the same thing. Once you don't have them, then you go to the packages install. That is where you are going to buy them. So you install it from that side. All right. Now you call them into the system to work for you. So just as my colleague did it in the first section, it's the same thing. Library is the word, the keyword that will go and call that particular package for you to work with. Okay. And then you set your API key. So the system, the OpenAKIO here is a library package written by the AKIO that is able to interact with their system. So the set API key here, once you put your key inside, then this package will now go and look for what it should do after you have set your key in it. All right? Then it will interact with their system, open the door for you to work with it. So this one doesn't give you the data. It only opens the door. Now, there are a list of countries that you can get from there. Okay, there are a list of countries. So there are a number of countries that have registered their census online. So you can sort it out by the country. Okay, so this list country will just give you the countries that you would see or you are likely to see there. All right, let me rather move to this one. I have my key in here. So I have run this one. Now, once I run this, great. So, country. So you see here, it will appear here. Because I have run this, so it will now appear here. So it's giving me 100 observations of 7 variables. So you see all the countries that are there, you will know. All right. And Ghana is somewhere. Yeah. Where is he? I've passed Ghana. Really? No, that's Guinea. Normally, Ghana will be hiding around. Okay. Sometimes it doesn't come in here, but there are a lot of them, okay? So, it is in there somewhere. All right. Anyway, you can look for that one, okay? Then they have some code IDs that they use, okay? Ghana, you will see it as GH. And then you will see some parameter IDs, okay? And then some timestamps in terms of the countries where you get them from. All right, but don't worry about this one. We just need to see what is there. Ghana, if you want to get Ghana, the Ghana ID is 152. Okay, Ghana ID is 152. So you use the ID to call Ghana. Your country, if you want to see that for your country, you go to the countries and then you see your ID for the country that you're working with. All right. So once you do that, this one will select for just Ghana. All right. And it will give you info on that. Okay. Now, the side that is much more important is this area. And this is where I had a problem last year. Each sensor is having an ID. And it is very difficult for you to know which sensor and what ID it is. That is the problem I had. So I just went to sit down one day and I was just thinking about how God created the earth. And I also wanted to be like God. So I created my own version of a human being. Please, do you understand what I just said? Does it make sense? Please, does it make sense? Please, does it make sense? It doesn't. Yes, of course. Because that one, you can't create it. Anyway, let's move on. That's just by the side. It was something I was just checking. I've realized that people are busy. Please, those who are busy, stop. Please stop. The response is not coming because you are busy. You want to do the things we asked you to do yesterday. Please, stop. Please focus here. We are not doing any coding today. You are not doing any coding. So just focus, okay? This one, the coding, you go and do it in your room. For now, I'm not doing any coding. So the problem is that it is very difficult for you to identify certain sensors because they come with an ID. And a sensor that may be 1 here, okay, the 2 will probably be in Indonesia. The 3 will be somewhere in South Africa. 4 will be somewhere in Japan. 5 will be somewhere in Russia. So it will be very difficult for you to be able to identify which sensor you want. And that is where it comes in that sometimes you have to make things very small for people to work with. All right? But I had gone through some of them, try and error, and knew some of the sensors, the ID. So I had one sensor by the code 79764. Okay? Now we can run this one and see what is there. So when you run it and it comes, it will give you some information on the data, okay? The longitude and the latitude is supposed to come, but some of them don't come. And sometimes you don't really get any information that you really want to work with to load the location or where it's coming from and any other thing, all right? But then you're able to have access to the data, okay? So after showing you all this confusion, I'll just, and you know, when you plot this one, it will plot. It will give you some plot, okay? So you can zoom in into the plot for you to know. All right. So this, now I know that this is ozone data. So even here, you are not even able to tell what data you are working with, all right? But you can see whether it's an ozone data, okay? And the values that is being plotted are there. All right. Now, because of all this kind of confusion and how to even know what this thing is and what it's supposed to get and all that, that is why I created that application. But it will be very ready soon on my GitHub, and you can have access to it and work with it anytime that you want. All right. But let me show you how it works. So this is a code that I wrote. All right. This is just one part of it. There are other parts of it. I will just give you. Okay. So this is the code. There is a part of it called global. There's a part of it called install, run app, and all those things. Okay. And inside here, there are other application type. This is CSS. Okay. And then more R codes, okay, to work with. So it's putting everything in terms of the Heckle and everything together into just one single code to be able to work with. All right. Now, when you're able to download it, you don't have to do any difficult thing. Okay, when you're able to download it, you don't have to do any difficult thing. You just have to make sure that you have all the packages that you need installed. All right. Now, once you run this code, you just have to run this side of it. Okay. There's one part called the shiny, which is part of the R. And then there's this one that will open your browser for you. But I can open this one for now. And this is all that you get. So, yeah. So this is it. Very simple, very easy to use, as well as at a point where you don't want to use OpenAKO data, you can use your own data to do your own analysis. All right. So in here, you still need your API key. You still need your API key for this particular one. So you go and just copy your OpenAKO API key, just as I have here. And then you only paste it here. You just paste it like that. All right. Now, after pasting it, you click on connect. When you click on the connect, it will now look for the server and then start interacting with it. So once it is done, it will show down here that connected to OpenAKO. Okay. It showed down there that connected to OpenAKO. And you will see that now you would have access to interact with the system. Now, you can go by city names, which is very easy. So if you want Accra, you can just type in here, Accra. All right. Don't worry about all these ones, these parameters, don't worry about them. And then you click on this. Now, when you click on this, it will search for, and it said it found 30 locations. All right. So you see, because of just the word Accra, it is looking for some of them in other areas. So you are concentrating around Accra here or in Ghana or West Africa here. You can now click on this and it will zoom in further to show where the other data sets are located. Anywhere you see this number, it means that in here, if it is 5, it means there are 5 sensors that are located in here. But when you see just blue like this, it means it's just one data. Okay, just one data set. Or one sensor. Let me put it that way. If you see this means that there are 5 sensors within this area. All right, within this location. Here it shows you that there are 3 over there. So when you put it on it, you see it will give you an area within which these 5 or these sensors are located. And when you click on it, it will zoom in further. So 3 are surrounded here around Asylum down, and then 2 in Nima. So to see the ones that are in Nima too, you can just click on that and it will give you the exact location of these 2. Okay, this is very simple. Now, you can decide on which one to choose. So you can click on the data that you want. And once you click on it, it will select it. So selected NEMA, all right? When you click on it, let's go back. This is Location Explorer. So here you are exploring the location of the data set. Okay, so we have used the Accra as an example. You can also use the country. Okay, so when you come here and then you type GH, that is Ghana. Ghana will come here for you. And when you click on Ghana and you click on the search, okay, it will be searching and it found 99. Okay, 99 census within the area. That is those that are registered with OpenAQ. It is not all the census that you see here. If you have registered with OpenAQ or registered under the OpenAQ agreement, then you will see it here. Other than that, it won't appear. So let's be mindful of this. So we don't say that we only have 99 or 90 census in Ghana. No. All right. Now, when you see this, this also gives you, so you see just around Accra, we are having about 87 census. All right. And in the northern region, we are having just about 2 in terms of what is registered under. And you can select which one you want. All right. You can also, at the same time, the ones that have been identified over the region, they also appear here. So you see, this is ID number 4, ID 5, ID 6, 7, 8, 9, 10, 11, and then C. ID, what? 9,764. This is still in Ghana. So you wouldn't know which ID code you are using to collect a particular sensor. So this is one of the reasons why I created this. So it's very easy for you to know which location and what sensor ID. So if you want to use it alongside with the R, you can come and look for the ID here, go inside the R, use the sensor ID to extract the data that you want. All right. So you can select any of them that you want to use. I have a dream that one day I'll stay at East Legon. So I'll choose one at East Legon. And then once you select it, you have fetch data. Now, fetch data is where you are really going to extract or get the data that you want. Okay, you are going to fetch it. So inside here, you have the location ID, and then you will see the coordinate system of the data or the sensor that you are going to work with. All right. Now, there's something that is telling me that with this particular sensor, there wouldn't be any data there because currently it is not live. It is not even showing any data. All right. Other than that, the ones that have data, it will show you the current value in terms of the whether it's PM 2.5 value here. All right, so I'll choose one that is currently available online, and we will see that. So let's go back to. Please, do you have Afri-Set, any available one? Afri-Set should be around here. Let me see. Okay. So I think this one. So that's Medina Zongo. All right. So you see, it is giving us the last reading of that particular sensor. So the latest reading, it's showing to be what? 15.59. All right. So, and this is having PM 2.5. Then you can select which parameter you want. So when it is having more than other parameters, okay, like let's say PM10, PM 2.5, ozone and all those things, they all show here. So if you have them, you can select them from here. But with the R format, the raw one with the coding, it is very difficult to be able to get that. So this one makes it also very simple to work with. So you can just select this one, okay? And then you can now click here for the fetch, to fetch the data. Okay, so if the data is available, it will start reading here, and then once it is ready, it will tell you. So it will tell you the values that it has fetched. If there are any missing data in that, it will give you less than 100%. Okay, it will give you less than 100%. So this also gives you an idea of the data that you are fetching. If there is no data, it will appear as 0. It will appear as 0 there. So this will let you know whether what you are going to extract is having data in there or not. I remember last year when we were doing it, those who were there, we would do some, we would try, and then you realize there's no data coming out, nothing to work with. All right, and it is very tedious to do it that way, but now it's very simple to work it in this format. And it will also give you the number of rows and then the parameter that you are working with. And the location, whether it is in hourly, the date that you select, okay, and when you are working with it. So it is today at this time. So it gives you all those information. You can decide to change the date range from here. Okay, you can choose which date you want, whether you want it from January or February or whatever. Okay, so this is how it works. This is the only part of the API. There are other parts of it. If you want me to show it, I will show it. Other than that, we can close now. So this is the part of it that is very, very much needed. And it's very simple. Very, very simple. So somebody will ask, can you download it? Yes. So this one will show you the data, the information you have, and you can decide to download it in what? CSV. This is getting some things in R if you want it. And then it can also get you the Excel format. And then this one can also zip everything and give you the information that you need. Okay. So this is very simple, very easy to work with. Sometimes too, you don't want to be downloading the data. You just need some information, especially, for instance, our brothers from the media. They just need what is going on, what is happening within a particular period. Do they have to download the data, work with it before they understand what is going on? No. Probably they just understand some form of graphs and all those things, so they can do their own analysis. Now, if you are such person, you don't need to download the data. You can go straight from here into the analysis section, all right? So do you have any question here before I move on to the analysis section? Any question? Any question? Any question? Before I go to the analysis section? Yes. The key. Yes, so when you register with the OpenAQ key on their page, on your page, right, it will appear there for the OpenAQ code. All right, and then you just copy it. You just copy that and then you input it there. Yes. Any question? Now, those who are very familiar with the Purple Layer 2 that we used last year, the difference between that one and this one is that this one will give you a lot of information on the data, as well as give you the freedom to choose which data that you want, those that appear there. And also you can do some analysis with it. With the Purple Layer 2, you can't do any analysis there. And also with the Purple Layer 2, you have to know the sensor ID. It is very important that for the Purple Layer 2 to be able to download a Purple Layer data online, you have to know the sensor ID. And I'll show you how to get that when I begin that session. But this one is very simple for you to work with. All right. Any question? Yes, please. Yes. Yeah, the R section side, don't worry about it, okay? The difference between, yeah, so the CSV and then the Excel. The CSV format is the one that you see just like the Excel one, okay? But it has a format that it saves with, which is comma separated values. So you will see a data like, let's say, values like this. Great. So you see this value, this side, and you see this section. What is separating them? Somebody will say a space. Somebody, in some data sets, it puts their comma to separate one row from the other. Okay? So that's comma separated value. So that's the CSV. And some you use tab. So it depends on, so that's the structure. That is all. All right. So you can, if you want to download the data, you can use the CSV or the Excel. That's this one, the two. Yeah.
I want to know what's so different about the RDS.
The RDS. So RDS, it's a certain format in, yeah, I'm coming. Let me. Great. Please, have you seen this? Are you comfortable with this one? Are you comfortable with this one? Yes. So this one, the system can work with it. Okay, but you will not understand this. So just forget about it. All right? These are codes. The system understands it. You wouldn't. All right? However, sometimes you can also decide to open it with, I decided to open it with Notepad for you to see how it looks like. But that is just to scare you anyway. But I can open with this. Okay. And into RD. Oh, yeah, I'm already working with something, so yeah, I shouldn't have done that. But yeah, that's it. All right. So it's a certain format that really works with systems, so don't worry about that. Yeah. Hey. Sorry. Yes. So yeah, any other question with this one before I continue? Any other question? Okay. So now let's move on. Now there's analysis. Once you have the data, you don't have to do any other thing if you want to continue with the analysis. You just have to click at the analysis section and you will see these two sections, sources and then upload CSV file. So if you have a data that is in CSV file, you can work with it without using API, anything. Okay? However, if you are working with the API, let's say you're a journalist, you go online or something is happening. Just like last 2 years, we were there and everywhere was just white. And the people were saying a whole lot of things. They caught one expert, and the person was saying that it is because companies are polluting a lot. And this was in the dry season. So if you say the companies are polluting a lot, then there is a problem. Because that was coming from the Harmattan. All right. So if you say companies are polluting a lot, then you are giving false information. And this, a journalist can take it up and it will be a problem. So if you're a journalist and you just want to view what is going on, this is just very simple and a tool to use. Now, when you choose this one, because we are fetching a data, this is very simple. So use fetch OpenAQ data, all right? This side. So automatically, what you have downloaded in the system is inside the same system. It is not going anywhere. And you can just click here, prepare data, and it will put it in a certain format that the analysis part will understand. Okay? It will reshape it so that the analysis part will understand. So once you click on this, and it is done, so it is ready to use. Now, there's something about OpenAir. I know my colleague did that in the first section with OpenAir. Their new version, when it comes to the summary plot, there's a problem with the new version, right? So the summary plot doesn't really work now. I don't know why they took it out, but it was a very good feature. So now I would have to remove that, but as it stands, this one won't work. So we can go and look at the time plot. So you can select which plot you want. Okay, some of the open air plots, you don't need to code them. Just select the right variables and you are good to go. So if you look here, you can select the time plot, you can select the time variation plots, the calendar plots, the wind rows, pollution rows, percentile rows, polar. Okay, all these ones are there for you to try your hands on. But we can look at the time variation plot. Then you choose the variable that you'd want. Okay, you just choose it. This one can select it by default, and then you can just go ahead and generate your plot. And this plot will appear for you. Very simple. Okay, so if you are a journalist and you are working with this, it's very simple for you to work with. And you can also put, so this one, as you see it this way, it will give you some information, but not a lot. If you want to see more, you can put just a smooth line in there, and you realize that this plot, just by adding that line, it will change a lot in terms of the view. Okay? It will help you understand what trend it is, whether it's going down or is increasing, whichever way it's behaving. All right? And somebody will ask, can you download the plot? Yes. So you can click here to download it in PNG, PDF, or SVG. Okay? Now, the time variation plot, you can also do that, just similar to what our brother showed. Yeah. So this is it. So it's able to give you which hour you are having a peak and which time you are having low values. All right. And then the monthly. So if you have more months, it will show. And then the weekends, which of the period do we have high? Which of the period do we have low? So for this data that we chose, I don't know why Wednesday is high like that. This is what? Medina, right? Okay. Wednesday is market day. All right. So Wednesday and Saturdays. Wednesdays and Saturdays are market days in Medina. So yes. So that's why you see Wednesday and then Saturday to be high like that. All right. So it gives you an idea. And then we have the calendar plot. This is the one I like very much in all the plots. Okay. And this will give you on specific days. So you can change this to any other color that you want. Okay. There are a few here. All right. Then you'll be able to know which day is having which value or which day is highly polluted. Okay. So this is very simple for those, especially within the policy section, those who don't need the science for anything, those who just want to know what is happening on the ground at a go. Okay. And with what data, within which location. So I think yesterday, Dr. Otulabi presented within the urban areas and was showing areas that were having high values and all that. If these sensors are registered similar to like on open air kill, right, it will be very easy for you to know, even just in your office, which area is highly polluted at a point in time. Okay, at a point in time, without waiting for you to get all the data sets before you now advance to do whatever thing you have to do. So, for instance, if you're a mayor or if you are tasked to be the one responsible for checking pollution levels, okay, or monitoring, this is a tool that you can use. Very simple. You just be in your office, the data that you have registered online, just click on it, go into the analysis session, just click on this. or the time variation plot to see what is happening, and an immediate response can be given to that. All right. And you can also break it with this our AKO format. So you see this one, you'll be able to know which one is good, which one is worse. Okay, this is the air quality index. So you'll be able to see where or which of the days that we had very high, which of the days that we had very good air quality system. Okay, that's when you select the WHO or the AQI breakings. All right. And you can also do a customization. So if you unselect this, and then you go to the custom breaks, okay, you can decide to put which value to what. All right. Which value to what? So depending on your limits that you have set, if you say that you go beyond 75, that is when you are approaching bad, then you can now set all those values that you want to good and then the rest to the others, and then you can see what is happening within some locations. All right. So this is very, very simple for you to work with. And you can export everything that you are working with also, okay? The metadata and everything. So this is the one we are working with at the moment. This is the columns that it is having, okay? So this is very simple. Very, very, very simple. Yeah, any question on this one? Any question? Yes. Yeah. Any question? No question. Yes.
Thank you for the presentation. My name is Pascal from the University of Environment and Sustainable Development in the Eastern region. So I want to know if you can import your own data rather than using the Location Explorer to get the data.
Yes. Please, can someone answer him for me? Please, can someone answer him for me? I want someone around this table to answer for me. Yeah, so I know why probably you'll be asking that.
They said I can.
They said you can?
Yes,
okay.
I don't know how.
Were you here? You were not here, or you've been here all this while?
I've been here, but I came a bit late.
Oh, okay, okay. Now I get it. All right. So yes, this system you can import in your own data. All right. And the section where you can import in your own data is under fetch data. Analysis. Okay. So when you come here, there are two options. It's either the one you have fetched from OpenAKL or the data you have. So you can just click here, upload. And in here, you just click on browse. You go to the location of the data that you want. Yes. So I have a couple of them here. I'll choose this one. So you see, even this is version 9. I've been working on this and I'm now up to version 9. And if I don't even release it, I'll be going to other versions even before. Yeah, so once you load the data, you see that it is what? File loaded. Check mapping, then prepare. So what the check mapping means is that make sure your columns align directly with what you want, especially the data column. Now, there are some data sets. In purple layer, you don't see date. You don't see date time. What do you see? Those who have worked with purple layer before, or those who were here last year. Purple layer, the data. What do you see? No. There's another one. There's created at. So that will be the time or date section. Okay? So when you come here, you have to choose. So you click here, and then inside your data, all the columns will be listed here. So you have to choose which one should be listed as your date. All right? Please, are we here? Please, those who are trying to code, stop coding. You can't code more than this code, so please. Please, stop that one. Yeah, we are trying to make your life very, very simple. If I had done the coding, I'm sure most of us would have just been going left and right. So let's follow the simple one and our lives will be easy, right? So you just have to select the date, all right? Then this is wind speed. Wind speed. Now, when it comes to air pollution or air quality, wind is very important. Direction is very important. Temperature is also important. But sometimes in some data set, your wind speed will either be saved as WS. Some will be saved as wind speed. Some will be given U. Okay? So, depending on what you are saving as your wind speed in terms of the column, then you select it here. So, in this data set, wind speed is WS. Okay? And wind direction is WD. Okay. As for the date format, when this one will automatically detect it. I did it in such a way that there are some formats that are very, very normal to a lot of sensors. So once they come in, they should be able to detect those ones. Unless probably yours is not part, then you can look through this and see which one is yours. So the YYY is for the year. We have 4 figures for the year. And then MM for the month. And then DD for the day, HH for hour, MM for minute. So this one is those who have a data that is saved as date time, okay, or timestamp. So you have that. And then we have some of them that the day is starting. So you go for the DD, MM, and the rest, okay. Now, once you do this, because this one, we are done with the mapping, we can now click on prepare the data. So we can prepare the data now for it to be able to do the analysis. So we click on it, and once it is done, it says CSV prepared. Then we can now come here and come and generate what we have. So the data, let me check the date of the data first. Then I'll be sure of what. Good. So now when you select time plot, you see the variables that are appearing here. So which variable do you want to plot? All these ones are not needed in that data set. Okay? So what do we want to plot? Maybe we want to plot ozone, NOx, maybe PM 2.5. Okay, so you can select the ones that you want to plot, and you can now run this, and it will give you a nice stacked on plots, okay, to show. So this one is for the NOx, this one is for the ozone, and this is for the PM 2.5. And this is running from 2018 to 2022, so that's what I really wanted. So when you come to the variation, the calendar plot, you select the pollutant that you want. Okay, so this is from your own data. So you may have different columns for different pollutant, all right? So in here, you can select, maybe we want to see what SO2, okay? And then the year. Ours is from 2018 to what? 2020. 22. So we can decide to choose 21. You can decide to choose 21. All right. And then let me go for this. And run. Then we will see how it behaved within that period. All right. So this is for SO2. All right. So we can decide to change it to PM 2.5, and we can decide to run this, and we will see how it will vary for those periods. All right. So, yeah. And somebody will ask, where is this data coming from that we are having very good air like that? It's definitely not Ghana, so don't worry. So, oh, yeah. Okay. So for this data set, it's not able to give us the AQI. All right. So this is what we get. All right. So depending on the data that you have, you can do your own analysis, okay, and then be able to tell which year was the COVID? 2019. Okay, I'm coming. So let's choose this, and probably this. Let's look at something. So you can also decide to choose whether it should come out in hourly or monthly. Okay, so you can put it in monthly form. Did I bring? I need water. Yes. So let's look at this. So COVID was 2019. And you see, just getting into 2020, you see that period. You see what is happening there when it comes to PM 2.5. Right? When it comes to PM 2.5. So you will see that in 2020, up to this period, it seems it's down. So you would even be able to look at the pre-COVID period and then after the COVID, what was happening. Okay, or what even happened. And if in Ghana, our lockdown was when? 2020. Okay, so assuming our lockdown was 2020, this is not anywhere in Ghana, but assuming our lockdown was 2020, and then you go into the calendar plot, it should give you some idea of when. So let's say the pollutant, for this one, you can do one pollutant at a time, okay? So no data to display. Forgive me online, I went on a break. So you see now everything has changed and it is a reverse, right? And you'll be able to see which days, all right? So this data set is coming from the UK. So there are certain things that is a bit different. So in the winter time, that's when their pollution also goes high sometimes. Okay. So you'll be able to know what happened on that day. And this is what the policy people need. To be able to know what happened on a specific day. And then you can use a time variation plot to know the specific time. So if it is vehicles, you know. If it is playtime for kids, you know. All right? And if it is a company that is polluting at night, you will know. All right? So these are some of the things. Now we can go to, now we have wind, so we can do some wind roses. The pollutant that we want, we are much more in love with NOx and other things. So this gives you a certain idea. It doesn't mean that it is indeed coming from there, but it gives you an idea of which wind is coming with this kind of pollutant, right? So it will give you an idea, oh, probably the source could be coming from the eastern side or the western side. For instance, when Doc was presenting yesterday, you realize that they said within a certain location at the hotspot, they put the sensors there, right? And then the sensor probably at a certain point in time will show that it's high and all those things. The pollution could even be coming from another area or within the same vicinity, but a different section, right? I think yesterday there was even an argument with some of them that how do you know this is the exact thing doing the pollution or it is so and so doing the pollution? How do you know that it is when some woman was passing and she was, blazing some tampe that spiked the thing? Because it can happen like that, yes. You can put your sensor on some tree close to a certain building, on uncompleted building, and you have our sitting there doing their own thing. Okay, once they light it up and they are doing their own thing, it will spike, and you will be alarmed. What is causing this? All right. So these are some of the things. So if you have wind data, it's very good for us to know what we are dealing with. So this is the pollution rose. I don't know why they call it rose. Maybe it's because of other than that. And then we have the percentile one as well. So when you choose the plot type, it also gives you some warning, okay, as to what kind of data it needs. So if your data doesn't have wind data, there's no need doing the polar plots and then the pollution this side of it, all right? So you can now choose this, and it will give you some in percentage forms, okay, how it looks like. Okay, so from which direction, from which area, and all those things. Then we have one of the plots I like is also this. That's the polar analysis. Please, if you can't mention it, take your time because the name is not really good. So, yes. So this is very nice, very, very beautiful. It looks like a donut, thank you, of which I'm very hungry. So this one will be able to give you which hour from which location. Okay? So if you look at this, from that's from 0 to 24 hours. And if you look at the area, so this means that from almost the whole day, winds that were mostly associated with this direction came with much more concentration. That's almost the whole day, or almost every day. And here tells you that in the night, so if there is a certain industry and you are suspecting the industry, this plot will help you give you some evidence. And I know some lawyers are now also going into this area. So Now, it will not only be autopsy report and gynecologist report, it will also be some of these reports that you submit at the courtroom to do your argument or build your argument. And it's very, very good. This is what we should be doing. We can't go fighting companies just because we know they can pollute. You have to, even now it's very difficult to win a case in court because they say that the evidence you have to give it to your opponent, right? For them to study the evidence before they come and meet you in court. So as they are coming, they have already prepared their mind. But when you have all these things, how do they even counter the evidence? Okay? Because you have this for several days, different wins, and you can now win your case very, very well with this, showing them that indeed, this is where it was coming from. So, for instance, if you have a sensor at this section, there's a company here, you have another sensor here, and this sensor is showing more concentration, and the direction is associated from this side, but this sensor is showing less, then it means that indeed it is coming from the middle. All right? Indeed, it is coming from the middle. So that one will pinpoint you down, and then you can get people on this. There is one part of it, I think this one. As for the offset and those things, you can go and try, all right? You can go and try. Good. So this also will give you by month, okay, by month, what is happening, from which direction. So this one will disaggregate them fine for you to do. So this system is very, very good, all right? It's not just having open echo, but at least you'll be able to do some analysis. I have 2 different versions of this. This was done with one colleague, and then I have another one which was done with one with Afri-Set, Dr. Victoria. So that is also, we are also going to mount that one also. That would also be available. That one also do more analysis, and it works with a lot of sensors. So the sensors, Airgradient, purple air, clarity, they all have different data format types. But the system will format everything into one way, and then you'll be able to do the analysis with it. And that one is in Python. So those who are very good in Python, you can also contribute to reshaping it into different, it's in Python, Java, and HTML. Yes, so those who are good in these areas, you can also see me, and then we contribute to it into making it much more better. But it's in the final production stage. So yeah. So this is what I have for the OpenAQ, and then your own data. Yes. So for the OpenAQ, this is done. Unless you have any other question. Because the purple layer, I won't go deep into it. I'll just show you how to pick the data, and that is all. No coding, like I promised. And you see, I deliver on my promise. Is that also? Yes, any question? Those who came last year and saw me yesterday and was like, hey, so today too, we are apprentices and we are... Please, are you okay? You okay? That's fine. So now I didn't disturb your head again. Yes, please, yes.
Presentation. What type of plots is, or what type of plots are these?
This one?
Yes.
Oh, okay. So this one is a polar plot. Okay, so this is polar frequency plot from OpenAir. So it uses the OpenAir package to do this. Right. So it uses the pollutant concentration that you have and the wind speed as well as the direction. But this one mostly uses the direction. We have the other polar plot that uses the wind speed. And then we have the wind rules that's also similar to these. Yeah.
Okay. Because it doesn't look like the normal polar plots I know.
Ah, okay, yeah. Yeah. But the reason why you see it as polar is because of the direction. So you see the north, the south, the east, and the west. Right? But inside it, it doesn't really fill it with that, what you are looking for. But that one is also there. All right? That's this one. So for this one, when you choose this, depending on what you choose here, the resolution. We can have, we can have something like this. So this is also there. All right, yeah. So I try to cover as much plot as I can. Yeah. Some you will not see them here. Yes. Any other question? Any question? Now, the last part of this one is that when you have a data and it is having from two different sources, let's say you have one from a model, one from an observation, and you want to do some evaluation, okay? As in compare the model data and then the observed data. You can use this section to do that. So that's the model evaluation statistics, all right? So when you go there, assuming, I'm not saying it is, but assuming our observed data, let's say is PM2.5, or let's say NOx, and then our modeled one is probably named NO2, okay? From this, we can calculate and do some analysis, and it will give us a lot of information. This is the number of counts. This is FAC2. We have the NB. I think our brother did that. And then we have the mean bias, mean whatever, and all those statistics. Okay, we can also separate them. One beautiful thing about this is that we can also separate them by month for you to know which month is doing better and which month is doing worse. So this is by each month. All right, and you'll be able to tell whether, just like we are seeing some 9 for August and all that, and then in September it is showing 0.7 for correlation. Okay, so this you can also do that. So if you have two different models or data sets from different the same location, but different sensors, you can compare them. Okay. You can compare them. Or if you have, let's say, the reference grade monitor as well, you can do some comparison to see whether your data is doing well with the reference grade monitor or it is performing worse. You can use that statistics to do that. So we also have the model evaluation part as well in this. The other one that we did, the Python one, that one is also having some special one where you can work with Airbeam. So those who know Airbeam sensor, the mobile one, that also can work with it, and it's very simple. Yes. So any other data? Any other question? Online. Yeah. What's the question, please?
Okay, so this is from Ali Voni. He says, is there a specific number of sensors needed in a location before being able to conduct the data analysis?
Is there
a specific number of sensors needed in a location before being able to conduct the data analysis?
No. So it depends on what you want to achieve. All right. So for what I said was with the law issue and then probably a company that you want to be able to monitor them. Okay, to be able to know that it is indeed coming from them. That is when you need more sensors. So if the company is situated here, you need a sensor at the east, west, south, north, including your wind. so that you'll be able to know which one is contributing to which area you are recording more. Then you can pinpoint down on it. So it's just like you triangulating that that company or something like that. But you don't really need much. In fact, you don't even have the money to buy much for just monitoring one company. So, yeah. Any other question? Was there any other question again? Okay, so that is done for what I have. So these are my keys. Okay, so this is from Pepole, the Pepole, and then this one is from the Opinekio. All right. So please don't copy this one. That is mine. Now, when you're able to download the Pepole downloading 2, all right, and you install, this is how it will come. For this one, I didn't create it. This is how it is. You have the home, you have the help, and then the links, and then here. So when you are generating your key, make sure the key you are generating or you get is a read key. Okay, so we have the read key, we have the write key. So just going for the read. You can also have a write key, which will help you to also do some interaction in terms of editing and all that. But each key gives you a certain permission level. All right. It gives you a certain permission level. So there are some keys you can use it to enter your hall, but you can't use it to enter the master bedroom. So that's how it is. So you can decide to go for both keys if you want to sleep. Then you now go to download. So once you put in your data, you go to download. Now this is where the problem is. The sensor index or indices, okay? This is the ID of a certain sensor, a Pepole sensor. And how do you locate this? Those who already have the sensors know what this index is. But if you are not the owner, you will not be able to know this. But this is how you can get it. It is not a hack. It is also not. But anytime you want to use it, please acknowledge the owner of the sensor, please. If you want to use any data from anywhere, acknowledge the owner of that sensor. Now you go to, if you want to get the index, okay, or the ID of the sensor, when you go to the Pepole map page, you see this is similar to what was showing on the on mine, but this one is showing the values. It's not showing the number of sensors in that area. But each dot here shows a particular sensor. All right. Now, when you click on this one, assuming this is what you want. Assuming this is what you want. When you click on this, you come here into the URL where the link is, the top there. You click there and you see select. All right. When you see this select, have you seen this code here? The numbers before the hash. Have you seen it? The numbers before the hash. This. That is for a particular sensor, the one that we have selected. So that's how you'll be able to get it. So you can steal this one. I'm saying steal so that you understand that whatever you are going to do, you have to acknowledge the owner. So you can steal that one, and the rest is giving you the coordinates. All right. So you can do this, copy, and then you come into here, and then you come and paste that value here. That is all. For this one, don't bother about it. The privacy, yes, some people set their Pepole Air to private. So when they set it to private, you will not be able to access it the way I did, unless you know the ID itself. Then you can directly use the ID. But that one, you have to go and select what? Private. Other than that, you can just leave it to auto. Okay. And then your time, UTC, you just leave it. You can select the period that you want, starting period and then ending period. Okay. And then the averaging, if you want your data in 60 minutes, that's an hour, or you want it in 6 hours or a day, you can do that. And then the fields. Here, if you don't know it, please ask so that they would show you, or you go to the purple air page and then know each data and what the name means. We have hardware, we have firmware version, we have uptime. Uptime is not the date time, so you can ignore it. All right, uptime is how long the sensor have been up. So if you include that data in your analysis, unless probably you want something else, but you don't really need it. Then we have the humidity. If you need it, we have the A and B. The humidity itself is calculated from the A and B, right? So anything you see A and B, the data itself is calculated from that A and B, all right? And then we have the PM 1.0. We have ATM. We have CF. CF is just the count factor, okay? The count frequency, sorry. So you don't really need that. So you mostly need the ATM, okay? And then we have this. So you select which ones you want, okay? So if these are the ones that you want, after selecting, now you see data points. For me, I am owing. I've downloaded a lot, so I'm owing. So my point balance here will give me negative. But if you are doing it for the first time, or you've not downloaded anything before, they give you some level. Depending on the number of data that you download, that will determine the points that is taken from you. And a high frequency data will take more, and a longer period data will also take more. So you may have to adjust. And then when you finish, you just click on get data, and it will do the rest for you. I have not filled in the others, so that's why the error is coming here. All right. So once you do it, you select where you want to save it. Select the directory. Then it will save it inside a place that you have chosen. All right. Then you get the data. Yeah. Any other question or any question? Otherwise, I just call it a night. Yeah. You want to ask a question? Oh, okay, yes. Any question? Any question? Any question? All right. So if no question, let me put in this announcement before I go. Please, there are other instructions for tomorrow. Tomorrow we will do programming. We will do Java and Python. Please, the instructions there, just follow and go by it. All right. But I will make it very simple for you. But please, just follow the instruction. Create your account. Make sure that you have an account on Google Earth Engine. Okay? And you can create something. The link to the data set, click on any of the data. You see open the code in so and so. Try and open it and run it and see how it appears in your system before tomorrow. All right. Thank you very much.
Thank you, Mr. Dr. Cosmos, for that wonderful presentation. We have our last two sessions for the day, and they are going to be both hands-on and practical. So to begin with our first presentation, that is going to be on the theme, air quality sensor building, covering hardware, software, and operations. And to deliver that presentation, we have Mr. Anorld, Sylvia, and Kimkpe from Afri-Logic Solutions. He is the automation and IoT lead at Afri-Logic Solutions. His work involves delivering a wide range of IoT and helps companies figure out effective approaches to overcome their market problems and technical hurdles to IoT technology. Ladies and gentlemen, with a round of applause, let's welcome Mr. Anorld.
Good afternoon, everyone. we just had lunch. I want to show some energy. Good afternoon, everyone. Great. I hope you all had great time. We all had, the food was great, and we enjoyed ourselves during lunch. Yeah, so just like it was mentioned, we're going to move into the practical session of today. I mean, for today, we've been hearing programming APIs, pulling data, and all that, right? We're going to look at the parts that allows us to actually collect that data, put it on the cloud, and then we can consume via the APIs we heard or talked about today. All right. So my name is Anorld Kimkpe. I'm the lead IoT engineer at Afri-Logic Solutions and also the co-founder for Crafted Climate. And today I'll be leading you through the workshop or the hands-on session saying air quality sensors, building from hardware, software to operation. So the reason why we are seated here is because air quality is actually a very big problem for us as a country, as a continent, Africa, and there has been rise in pollution in terms of the air quality. And what actually is the problem now is to identify where the hotspots are, where the pollution levels are coming from. And the main issue is the lack of critical data. The gap there is we don't have enough data to be able to pinpoint out exactly where these problems are coming from. So what we do here, what we are trying to do here is we're going to find a very simple way we can build sensors that allows us to collect data, sensors that are not expensive, sensors that are cheaper, which we call the low-cost sensor. Now, on the market, there are actually sensors that records or helps us collect this data, and mostly actually they're expensive. Most of them are BAMs or reference monitors, and they kind of cost up to from $10,000 upwards, and it's expensive for a simple municipal community to get one and use that to monitor air quality. So what do? We come up with a solution where we design low-cost sensors. When we say low-cost sensors, they are sensors that behave like the reference monitor, but we don't use expensive components, but we use components that can collect the same data the reference monitors are collecting. Maybe in some cases they will not be accurate. There are ways that we can make them as close as possible to data or values coming from the reference monitors. So in our case, what air quality actually is for us is the amount of particles in the atmosphere or the gas, in this case, the temperature, and then the cost reality when it comes to buying these sensors. So for our workshop today, we're going to be looking at specific parameters we'll be collecting, specifically particulate matter. We'll collect eCO2, equivalent CO2, which I'll explain what it means, the difference between that and then actual CO2. And then we collect TVOCs. Then we'll look at temperature and humidity data, which is actually one of the important factors, especially when it comes to operation and calibration. Then we'll look at the cost reality. Like you said, reference monitors cost about $10,000 and above, and it's expensive. So today, what we're going to do is we're going to build our own low-cost sensor. Now, what do you classify as a low-cost sensor? A low-cost sensor would be a sensor that will cost between, let's say, from $10 to about $500. All right? If you buy a sensor and it's more than $1,000, is the collection or the way you classify it as low-cost sensor is going to depend on what it's doing. But for now, we want to build a sensor that is below that price level. We build a sensor that is below $500. All right? And converting $500 to Ghana cedis, you're approximately 5,000 and something Ghana cedis. Right? But for our setup that we're doing today, we're not exceeding even 1,000 cedis. So with 1,000 cedis, we can build our own low-cost sensor, write our programs to it, and then collect air quality data. And the way we are viewing the graphs and then the data on the screens through the web interfaces, we can do the same with our low-cost sensor that costs less than 1,000 cedis. And that's what we'll be doing today. So today, the sensors that we'll be looking at are the Sensorin SPS30, which is a particulate matter sensor. So it measures the particulate matter or the particles in the air, all right, by using a laser technology. Then we'll look at the ENS160, which is an indoor gas sensor. So it measures the TVOCs, the total volatile organic compounds, and then it uses some algorithm to calculate the equivalent CO2 of the TVOCs it has measured. Then the very important factor again, which is our temperature and humidity sensor, the AHT2X, which will allow us to collect temperature and humidity, allows us to do for compensation and then calibration of our sensors. Like I mentioned, the eCO2 we are measuring today is not actual CO2. It is equivalent CO2 based on algorithms that are run with the TVOC values, right? Now, the difference between the ECO2 and then the CO2 is, for ECO2 is generated by running data values from the TVOC sensor through an algorithm. Then we have an equivalent CO2 value that we think we are measuring inside, all right? And then the actual CO2 sensor is actually, or the CO2 is measured by a sensor that's electrochemical or runs the NDR technology. So in this case, we are using laser to measure the CO2 particles in the atmosphere, which is more accurate than an algorithm. Is that okay? So that's the difference between the ECO2 and then the CO2 values we'll be measuring. So today, what we'll do is we'll go into groups, and then each group will have a kit that we'll be using to build the sensor from scratch. Again, this sensor is labeled an 1,000 Ghana cedis sensor, and it will do exactly what all the other sensors you buy on the markets do, all right? So the brain of the sensor will have a microprocessor in there, and then we connect our sensors to the microprocessor. The microprocessor will take the data from all the sensors, all right, and then compute it. If we need to convert PM2.5 to AQI index, it will do that in there for us, and then display it on a screen and then on our mobile phones too. So now we've moved from the hardware layer, right? The team was building sensors from hardware, software, and then operations. The hardware layer is picking out the sensors you need to build your low-cost device. Now to the firmware. The firmware is basically the programming we've been mentioning today, all right? Now, you write programs in Python, C++ on your machine, and you run them, they work perfectly. But for the hardware, that's the chips that will be running our code on. We call them firmware. And they're a bit more complex than running an actual Python program because you need to understand how the hardware works and all those things. But in this workshop, it's covered for you. So we don't need to go into the technicalities or the complexity of programming the hardware, all right? So we'll collect the sensor data, we'll process the signals, run them through some algorithms to make sure that we're collecting the right data, and then we'll calculate the air quality using the US EPA standard. Then we'll display the results on our screen, which you find in the box, and then on your mobile phones. Then we go to the operations layer. Now, once you've got your hardware, you've designed the firmware, you write a good firmware to collect the data. You can't just keep collecting data and then think it is okay, it is fine, or it's accurate. There are times where your sensor will be on, you think you are collecting data, but there's no data coming, or you think you are collecting accurate data, but it is not accurate. There are some things that we need to do in terms of mounting our sensors. So in mounting your sensor, you should put it above 1.5 to 2 meters high from the ground. And then some of the sensors need time to warm up to be able to collect accurate data. So they don't just turn on and then you start collecting data. They need time to warm up, make sure they are in the right state to actually collect data. And for us, the sensors we are using here needs about 30 seconds to warm up, and then they can start collecting true data. Then calibration. So remember I said that the particulate matter sensor actually picks or uses laser to calculate or count the number of particles in a certain gas sample. Now, these samples or particles in the atmosphere can be affected by moisture. So when the weather is very cold or when it has rain, the particles can actually absorb the moisture, okay? And in this case, because you are using laser, water can reflect a lot of light. So we need the temperature and the humidity data, ambient temperature and humidity data, to correct for the moisture the dust particles have absorbed. So that is why we need to keep temperature humidity for our calibration and then to fix any tropical challenge that we experience. Then the maintenance part. Now, if you're building a low-cost sensor, the fact that it is low-cost doesn't mean you should pick any sensor or any cheap sensor, all right? You will see a low-cost, a sensor that costs $50, measured PM2.5. There's a sensor that costs $10, also measures 2.5. Now, we know that it is expensive because it is probably better than the $10, and a lot of work has gone into it, all right? So if you are picking a sensor, we need to make sure that we're picking the right sensor for the right job, and I've read the specifications. Some sensors are certified, just like the SPS30 that we're using. It's a certified PM sensor. So we know that the data we're collecting from it is right about accurate. It's from the go, all right? So what this means is, and for maintenance, some devices or sensors, based on the environment, you need to be doing regular maintenance, a month maintenance, 2 months maintenance. For example, if you deploy a PM sensor in a very dusty environment, you should know that at some point it will get clogged with dust inside. So you need to be going there, maintenance, to cleaning up the dust inside the fan. But for us, again, the reason why we chose the SPS30 is it has an internal self-cleaning system, all right? So once dust accumulation is detected, the sensor itself can actually spin up the fan at very high speed to blow out all the dust inside it, and then it's good to go for the next round, all right? So when you're selecting sensors, these are some of the things you should also put in place. Okay, and so that'll bring us to Crafted Climate. It's a climate tech company that I work at, and what we do here is also develop low-cost sensors, right? So we have sensors that measure gases, we have sensors that measure particulate matter, and we have the CrowdSense EMV for particulate matter, temperature, humidity, noise, UV, and then light. And then the gas module can measure gas sensors like methane, CO2, and these are sensors that are actually under test and being calibrated most of the time to check how the data accuracy looks like. So what we are trying to do is we are trying to empower us. The more reason why we are here, that we don't need to buy expensive sensors to be able to collect data in our environment. You don't need expensive data sensors to close the data gap we're experiencing here in Africa, West Africa. We can build our own sensors here locally and then collect the right data to make the right decisions. Now, one of the reasons why we're also championing the low-cost sensor is these foreign sensors are not designed for our environment. They're not designed for our climate. So you can buy sensors and then mount them in a certain area, and then for some time you realize that it's the sun scorching it had made it brittle, it's breaking, it's falling apart, and all those things. So for us, one of the major goals is to make sure that we design sensors that fit our environment. You can put it in any environment and it will survive. Okay. So for today, we're going to be jumping into our session very soon. What we'll do is we'll do the hardware walkthrough. We'll see the data displaying on the screen and on our mobile phones. Connect to Wi-Fi, and then we'll open the dashboard to see what's happening. So before we go into the next session, I'll need us to go into groups of 10, 7 tables or 7 teams, but each team has 10 members in there. I'll need help organizing that. Okay, nice. So I'm guessing every table has a bowl, a microwave bowl, a bowl in front of it. I mean, it's not for pastries. There are actually components in there that will be connecting. So if you open your kit, all right, you're going to see a variety of components in there. And I'm guessing, yes, not most of us have a lot of electrical or electronic skills at this point. But this is going to be fairly simple. It's going to be easy for us to connect because I'll be guiding you through it. So in our kits, we have the microcontroller we talked about. We have the particulate matter sensor, the SPS30. We have the ENS160, that's the equivalent gas and TVOC sensor. And then there's a big screen inside the kit, which is going to show us the data our sensor will display. All right? Now, currently on the board, you see a breadboard. The breadboard is the white thing that has the microcontroller and some wires connected to it already. That's what we call the breadboard. As to why it's called a breadboard, I don't know why. At least it's serving its purpose in the kit, right? So now, what we want to do is we are going to connect the sensors to the microcontroller. But before we connect sensors, we need to understand that the sensors are also electrical components that needs to connect to a main processor, and then the processor should request for data from the sensor before the sensor can give it data. So we are not just going to connect it anyhow. We're going to connect it in a way that the microcontroller can communicate with our sensor. To save us some time, we'll not be doing programming. All right, we'll not be doing programming today. We're going to do the electrical connections and then see how it's going to work. So in this case, all our sensors have a protocol they communicate on that we call the I2C, interconnected circuits. Now, in this way, it allows all the sensors we'll be using to act as a slave to the microcontroller. So the microcontroller becomes the master, and then the sensors become the what? The slave. Okay? So it means that all the sensors will be going to one port for today. Okay. So now, if you pick, let's pick the ENS 160, the blue gas sensor on it. This guy. This guy. Okay. 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 Also, please, to be safe and to prevent short circuiting, if we have open bottles of water on the table closer to the kids, we can put it down or move it away from it, yes, so that we are all safe. Okay, so once we pick up the ENS 160 sensor, if you look on the sensor, there are some indications on it, right? You see V in, you see 3V3, you see GND, which is for ground, you see SDA, and then SCL. Now, SDA is not the church. SDA is the data line that the sensor will be passing information through, right? So it's called the serial data line, okay? And then you see the SCL, which is the system or the serial clock. Those are the two lines we'll be using for today in combination with the V in and 3V3 and then ground. So if you look inside the sensor, for some of you already have it connected. For some of us, we don't. You need to pick 4 wires that are joined together, 4 jumper wires that are combined together already. So we don't need to separate them. It's already connected. So the jumper wires, there are 2 types. There is the male to female and then the male to male. Male to male has 2 pins at the ends of it. And then the male to female has a pin and then a socket. So we pick the female, male to female. The one that has a pin and then a socket. Male to female. All right? And then we're going to connect the female part of the wire to our ENS sensor. Now you're connecting it to these 4 parts. The 3V3, the ground, SDA, and then SCL. Those are the 4 parts you connect the jumper wire to. 3V3, GND, that's called the ground, SDA, and then the SCL. So you connect the 4 sockets to the 4 pins coming out from the sensor in that order. That's it. They have 2. Okay. Come again. Before we jump into connecting to the ASP. No, not connected to the ASP now. Once more. Yes, so they're bringing one. Okay. Are we good to go? Awesome. So now that we have our wires connected to the sensor, we want to look on the breadboard. Now, you pick your breadboard. The breadboard is the white flat material you see on the table. Yes. So this is a breadboard. This is a breadboard. All right? So you want to... as to why it's called a breadboard, I don't really know. Google it. All right. So once you pick up our breadboard, the wires we connected to the ENS 160, that's the gas module sensor, we're going to connect them to this board. Okay. So if you look at the board on the right side, if you look at the board on your right side, right, there are number indications there, right? So you go to line 20. Go to the line 20. For those of us using the longer boards, yours are in 10s, 20, 30, 40s, right? So you can count from there. So line 20, and then you take one end of the jumper wire you connected to the gas sensor, put it in 20. You do the same for 21, 22, 23, and then 24. All right? So in that order. So you have 4 male wires right now. You have 4 wires you need to connect. Okay. So when you look on the breadboard, yes, so on the breadboard, there's a line that is marked as 20. Okay, we want to use that as our starting point. So pick one pin from the jumper wire connected to the sensor, any pin, right? And then connect it to line 20. In fact, wait, don't use any pin. Let's make it order. 3v3, the line that is going to 3v3 on your sensor. So this is your sensor. You've connected 4 wires to it, right? The 3v3 is the first pin there. So mine is line white. So I'll trace the white line and then I'll put it on line 20. All right? So you know 3v3 is going to line 20. Then we'll go to the next one, which is ground. We'll trace the line for ground 2, put it on line 21. Then we'll trace the line for SDA. You put it on line 22. You trace the line for SCL, put it on line 23. And then we are done setting up the sensor for now. Is that clear? Or I have to go over again? Okay. Okay, so you look at your gas sensor. It has 4 pins. Okay. The first pin starting is 3v3. You have a line connected to 3v3. Okay. You trace that line to the end of the pin. And then you put the pin in port 20 on the jumper board. Or the breadboard. Okay. Then you go to the next pin, which is the ground, GND. You trace that line and put it on line 21 on the breadboard. You do the same for SCL. It goes to 22, and then SDA goes to 23. So you have, when you're done, you have a vertical connection of your pins, right, from line 20 to line 24 or 23. 20.
Yeah, if I may ask,
yes.
Why specifically pointed 21, 22? Why is that?
Okay, so on the breadboard, current flows horizontally. So current flows from this point from left to right. So if you want to connect a sensor and then get power into it, it needs to be on a new line. If you put all the 4 sensors in the same line, they will short circuit. They will all be receiving the same current, which you don't want to. Current should flow in a circle. So it has to leave one line and go to the other. So if we put power here on line 20, we need to collect the power for a sensor that will use power, and then for communication, we have a port for communication, we have a port for ground. Else we can't put all of them in one line. Power and communication cannot be in one line. So they have to be in separate ports. All right. Yes, it doesn't have to be 20. You can go to any part, but it has to be in line. It has to be horizontal. Yes. Okay. Can we continue? Are we good to go? Okay, now let's pick the second one, the display. All right. Again, for some of us, we have it connected. For some, we don't. So we'll go through the same process of picking 4 wires that are already joined together, male and female, and then we connect it to the back of the LCD. All right, so I'm saying that we pick our display module, the LCD, okay, and then if we don't have our wires connected, we connect them, the male to female jumper wires, and then if you look closely on the board again behind it, okay, the black chip there, you see that it has the same labeling, VCC, ground, SDA, SCL, right? So we're going to connect it the same way we connected the sensor from line 20 to 23 or 24. Right? So for 20, we should put 3v3 for the gas. So we're going to connect the VCC of this board to port 20. So VCC, yes, the left side on the same line. On the same line, yes. Now VCC 3v3 means power. Okay, so that is where the power is going to come from to turn on our devices. Okay, so that line is for power. So line 20 is for power. Are we good? Okay, then we'll go to the second one, which is ground, GND. So behind the board, look for the labeling for ground, trace the wire, and then connect it to port 21, because that's where we put our ground for the gas sensor. If you rush, you may disconnect something and then it won't work. Okay. So if we are done with the ground, we can do the same connection for SDA and then SCL. All right. So SDA will connect to the sensors SDA pin 20, port 22. All right. So please, before you connect, let's confirm this. Your port 22, which line is it connected to on the gas module? Is it SCL or SDA? On your breadboard, it's SCL. 22 is SCL. So it means that on the LCD, you connect SCL, the LCL line to 22. Yes. So all SCL has to be in the same line, all SD have to be in the same line. Because I'm not going to say it. They should find us. Okay. Good. Yes. Okay. So, guys, so this line is cutting power from here. So it has to be closer here. So this is line 20.
So we should put it somewhere.
It has to be, so like I said, current flows from like this.
Okay.
So if you're connecting any new line to this port 20, you put it here.
So close.
Yes, close to it.
So you have to remove it.
No, this is fine. Don't remove this.
So you want to bridge it.
We don't have enough jumper wires to bridge, so we will connect to that side. Yeah.
SDA is orange here. Not the color.
Okay, you can use colors. Yes, so he's showing you the color here. Then you also look at the line. Yes.
Okay. So
they are not the same colors or same connections. So okay. So when you say
SDA here,
yes, find SDA here, you trace it and he will tell you the color.
The number
connected. Yes.
That's what I want the number here, because the number here.
Let's use the numbers here. I can only see the color.
Then with the color you can trace the number.
So when you mention the color,
Give space. The next one is SCL. That's the red.
Red.
So it's easy
to check your SCL.
Nice work.
No, it's not the number. Yeah.
Okay. I can see that we've already connected the rest of the pins. You're not done yet. So it connects to the SCL of the sensor, the gas sensor. So SCL of the LCD will go to the same pin SCL of the gas sensor. We are getting, that's the next one. Okay. At this point, we can verify that we've connected our SDA, SCL pins, the two sensors. So we've connected the LCD, we've connected the gas sensor. Now the next thing to do is, like I said, to be able to collect data, the microcontroller, that's the ESP32, the black thing on the breadboard, right, needs to read data from the sensor. Now, this microcontroller there can allow us to connect to Wi-Fi, Bluetooth, all right, okay, and then collect the data. For now, we're using Wi-Fi, but before we start collecting data, we need to bridge the sensors and then the microcontroller, all right? So to do that, we have an extra male-to-male jumper wires in there. The male-to-male jumper wires are the wires that have 2 pins at the end. So pin, all right. We need 4 of those. All right. Now, look on your microcontroller, the ESP32. The top left corner, you see 3v3 and then ground. Do you see it? The top left corner of your microcontroller. Do you see 3v3? Yes. So we take one single jumper wire, connect beside the 3v3 pin, and then go and connect to the sensors, where your sensors 3v3 is, on line 20. Do you get it? Okay. So we'll do the same thing for the ground. Under the 3v3 pin for the microcontroller, there is GND, that's the ground. Connect a male-to-male jumper wire at the GND, and then go and connect it to the ground of your sensors, where the GND port is for your sensors. So GND is set. All right. Okay. Hello, everyone. Please, are we good to go on the next steps? You have an issue. Okay. I'm just going to check. Yes. Okay, are we good to go? All right. Now, the next step is to connect the communication lines. The communication lines are the SDA and then the SCL to our microcontroller. Okay, so we'll start with the SDA. Look for pin 21 on your ESP32 or the microcontroller. Pin 21. Yes, on the same board. Not port 21, pin 21 on the microcontroller. Are we there? Then we take a male-to-male jumper wire, connect it to pin 21, and then connect it to your sensors SDA. Pin 21 will go to your sensors SDA. So which line is SDA here? Pin 21 is here, somewhere here. Yes, on the microcontroller. So on the microcontroller, there are some indications on markings. Yes. SDA. So pin 21 goes to SDA. D21, yes. So D21, pin 21. D is for digital, so. Okay. Are we good to go? Can we connect the next wire? Okay, so the next wire is going to pin 22 or D22 on the ESP. So yes, so last but one, yes. And then it goes to your SCL part of the sensor. So pin 22 connects to the SDL port of your sensor on the breadboard. You need microscope. 21 goes to SDA. Elias. Please check your mom. Come again. 22 is SCL. Yes, and 21 is SDA. So at this point, we've done 95% of the work. The next thing we'll do is to give the sensor or the kit power. It should turn on. Remember we said the warm-up time, 30 seconds. So we have to give it 30 seconds for it to warm up. Then we can start collecting data. So, yes. So on the tables, the kit will come with a USB Type-C cable. So give this one to someone who does that. Yes. So the kit will come with a USB Type-C cable. You connect, the moment you connect it, your screen should light up. Yes, you can connect it. Yes. The moment you connect it, your screen should light up. Yes, you've done a good job. If it lights up, yes. Okay, now I'll need to come and adjust the brightness for you. And then, Elias. So for some of us, our screens may be dim. All we need to do is just adjust the brightness at the back, and then it will work. Could you topple it? Okay. All right. Please, if your screen is blurred, you can alert me, and I'll adjust the brightness for you. I'll be there. You can't see any writing. So I'll come to that. Okay. Sorry. Okay. Can I see your screen?
It's going to be 30 seconds.
It's past 30 seconds at this point. Could you turn show me that? Okay. Yep. Okay. So once your screen is lit up, you see that there are some instructional display on the screen. It's saying Wi-Fi dashboard. Now, for every kit that you have, it has a unique Wi-Fi name. So for your table, if you look at the cover of your kit, your Wi-Fi name is there. So Crafted Climate AQI3. That is mine. So you look on the cover for your kit. 2. So, okay, great. So now what the ESP is doing is the screen is not on.
Like it's on, but then the writing.
And so yes, so screw. Adjust the brightness on this. Okay, so please, let's wait before you connect. Let us wait. I want us to do something. Now, every table has a unique Wi-Fi name for their kit. We don't want you to connect to another table's Wi-Fi, right? So if your cover has Crafted Climate AQI3, you go to your Wi-Fi networks, connect to Crafted Climate AQI3. That's for your table. So don't connect to somebody else's Wi-Fi. The password is also displayed on the screen. In case you don't see it, it's 1, 2, 3, 4, 5, 6, 7, 8. That's the password for the Wi-Fi network. 1, 2, 3, 4, 5, 6, 7, 8. 1 to 8. You all on the table can connect to your sensor. It can serve up to 32 people, so you're fine. It's not coming. Okay. confirming the connections again. Okay, let's see. Yep, this is where the issue is. So we missed one port for the ground. So this is going to ground. So it's the second pin. All right, I think after this we should be fine. Good. Yeah. It's 2. Please, who has been able to connect? Awesome. Yeah. Their phone, yes, or their laptops. Have you been able to connect? Awesome. Yeah. So if we connect successfully and we enter the IP address the microcontroller shows us, we should have this interface displaying the air quality index. Okay, for us. So we are at this. A question was asked on what kind of data are we collecting, right? So at this point, we are collecting PM1, PM2.5, PM10. We are collecting ECO2, equivalent CO2. We are collecting TVOCs, the total volatile organic compound. And we are collecting temperature and humidity. All right, so these are the data we are collecting. So if you scroll down on your web interface, you see all the data points in a card below. So if you are using your mobile phone, you can scroll down, you see the data points for temperature, humidity, pressure, and it's real time. So if you want to test if the sensor is actually measuring, you can pick the CO2 sensor and blow air into it for like 5 seconds. You see that the data will change. Why? Connect with a mobile phone and let's see. Yes. No, it's not showing the cards. Yes. Be careful. Have we been able to connect? It's not showing. It's 192.168.4.1. It's still. Let's see. Oh, sorry. Let me see your Wi-Fi.
Yeah, it's connected to this.
Okay, AQI2. Yeah, different browser. Let's see. Let me just reset it. Okay, so I've reset your sensor. So wait for like 30 seconds and then we'll connect again. So if we connect with our mobile phones, you should see all the parameters. It's showing now, yes. So yes. So you are seeing 0 because the sensors are still warming up. So there is no data coming at this point. So now you see, yes. So if you want to interact with the sensors, for the CO2 sensor, you can blow air into it, and then the values will change. You see that it will increase from 400 ppm to, this is a CO2 sensor. And that is in real time. So this is how you can build your low-cost sensor under 1,000 Ghana cedis, and you should be able to display the data on your mobile phones or devices. Now, there is now at this point, the only form of connectivity you're having here is Wi-Fi, and it's local. Nothing is going to the cloud. All right. So here we are not collecting data. We are just seeing the data and then viewing it. If you want to collect data, there are a lot of options we have. You can connect an SD card module. So we store the data on an SD card. And then we can say, okay, instead of connecting to our local Wi-Fi, we'll connect to the internet and send the data over to cloud. All right? So, okay, I'll be there. So we connect the data over to the cloud. And one major challenge when it comes to developing low-cost sensors is connectivity. All right? So to pick the right connectivity model or the right medium to use, sometimes you need to go cellular. That means that you need a modem. Sometimes you need to go Wi-Fi. And if you go to remote areas that do not have Wi-Fi, it will not operate. So you have to switch to cellular or do mesh networking with LoRa. Okay, so that's one challenge with low-cost sensors, connectivity. But once you figure it out, you are good to go. So you can collect data, store it to the cloud, and then use it for analytics or what you want to use to do. Any questions? Press the EN pin at the top, right, the right side of the USB port. Please, the microphone.
Okay, thank you for your presentation. My name is Ibrahim from Côte d'Ivoire. I'm a data scientist. So, based on my experience, I noticed that one of the challenges that we meet when we are building a sensor like this is powering the system. So, I want to know how you manage with this matter. Like, if you want to, this is a prototype.
Yes.
If you want maybe to deploy it in real life, how you manage the powering way? I mean, if you want to power the system.
Yes, yeah, true. Actually, power is also, or keeping the system alive for a long time is also one of the biggest challenges too. So most of the times, the low-cost sensors we see need to be powered directly to a wall socket or USB cable to work, right? So what we do with power is, it depends on where you're going to mount it to. If there is no power available there, it means you have to switch to an alternate method like solar panel, all right, or running on batteries for a long time, or long time batteries. Now, there are batteries that run for 10 years, okay, without any charge. So you don't need to charge them. They can power your devices for 10 years, but there's a trade-off. The trade-off is how often your device will come on to sample. Now, when your device comes on and is collecting data, it draws a lot of current, especially the PM sensors, right? So drawing a lot of current, when it comes on for over 1 hour, you draw current that will reduce your battery level. So it means the sacrifice is you need to be sleeping, or your sensors need to go to deep sleep to conserve power. You only come on when you're collecting data, and then you go back to sleep. In this case, your sensors can run on battery or solar panel and can run for a long time.
Okay, thank you. I have another question. Like, I saw you use Wi-Fi, like communication protocol.
Yes.
Let's say that you want to maybe collect your data. You don't want to go to the field each time. You want to implement your system. And then after, you want to collect the data from your home. Which kind of communication protocol can we use?
Okay. So, because this was a demo prototype kind of thing to set up under 1,000 Ghana cedis, we are not using any external communication module. We are using the Wi-Fi, which can talk directly to our mobile phones to view the data. Now, if you want to store the data for future analysis, I mentioned that you can connect an SD card to your microcontroller. So your data, whilst writing to Wi-Fi, is saving on the SD card. So anytime you need to do analytics, you can come and pull out the SD card and then read the data from it. Or you can connect your sensor to a server. Okay, but that means you need internet connection. Right? So once the sensor collects data, it will send the data over the internet to your cloud server or database somewhere and store it. That means you can access the data remotely. Right? So you have different options of storing or preserving data for future use. Right.
Okay, thank you.
Welcome.
Come with the complete, the housing, I mean, so that at least we'll see what
it looks like.
It looks like. Did you come with that?
No, but I display that in the slides.
Oh.
So there's a picture of it in the slides. And tomorrow we'll bring them, and then we can also have a look at how they look like
Okay.
actually in physical.
Well, has there been also maybe challenges? I mean, looking at how we have to fix in these wires, maybe the location where they are located, maybe wind or something. Can't it maybe alter, shift some wires and all that? As those things like that be considered?
Yes, there's been lots of challenges. Actually, for the first iteration of our board, there was a lot of wires running around. And the first time we mounted it at Afri-Set, when the rains came, they actually went into the sensor model and then bent everything there. All right, but that was a learning curve for us. For us, we designed PCB, so we designed a PCB, so it's a compact board. You don't see wires running here and there, and then you connect your sensors to it. And then the enclosure, which plays a very important role. It needs to be waterproof.
Yeah.
So we designed the enclosures to be waterproof so that water does not go inside. Yes, still air can go for the sensors to measure the particulate matter in them and then send you the data.
Okay.
Yeah.
Great. Thank you.
No, sure. Maybe the sensor, they have to push it. Check the connection. Any question?
I just wanted to find out. Thanks again. I think this was a really good exercise to give an insight about how these sensors work. But if I may ask, sir, have you tested your brand against some of what is commonly used, whether in Ghana or other parts of West Africa? Has that been done? A kind of a comparative study, maybe not widely, but have you done something like that to have an insight on how effective this could be for, commercial purposes?
Are you talking about this setup?
No, your sensor, not this setup. Your sensor, yeah.
So we've actually been developing the sensor for over 2 years, and there's been lots of changes because of experiences we meet. Sometimes your hardware will work fine, and then the software running on the hardware is the issue, right? So for us, we are still in the phase of getting things actually working properly, and then we can actually go into the market we actually have to certify and then go into the market first. So we are still in the process of development.
Okay, thank you once again, Anorld. So is there a timeline for this? I mean, having the products, your products in the market, is there a timeline for it?
Yes. So we recently joined the Micro Sensor Air Challenge. Then out of that challenge, we also experienced some downfalls and challenges in there where the device works perfectly, but then the data that is being sent or to the server is not being received. So in that state, the hardware is okay, but the data is not coming in the on the server side. And that's one challenge that we experience. So for us, we need to come back, set up or write a proper firmware, install on the device, and then come to test for certification. Then we can go into the market for that.
Okay, I think you should just keep us up to date because so that way too we'll see how we could also excuse me, partner with your team and see how we could. At least this one is homemade, is our own, so we have to see how we can take it up from here and begin to use. So please just keep us up to date.
Sure,
Thank you.
we'll do that. Thank you.
Yes, thank you for the insightful exercise.
Thank you.
So it's more of a curiosity. Can you please give me like a short summary on, for example, how would you calibrate this low-cost sensor? This is comparing it to what's the model called? The one you...
The reference monitor.
The reference model.
Yes.
And also, since we are building these sensors for our context, what are measures you might take? This is comparing it to the hot air or the power shortages or let's say connectivity problems. What are measures you take?
Okay.
Yes.
So for calibration, the first option is, or the first thing we do is the reference or the co-location with a reference monitor. What happens is you co-locate your sensor with the reference monitor for a period of time, and then the data collected from both sensors is compared, and then you generate something we call the correctional function. That would make sure the data you're collecting from your low-cost sensor is almost as equal as the reference monitor. And in that way, you have a calibrated sensor that's reporting real data or accurate data. And for the parts where to prevent shortages and distraction of the board, I mean, those things will come with experience. there are times where you, as a hardware engineer, think that you have everything figured out, and then you take it to the field, it's responding different. All right. So I can't stand here and say, okay, you need to do this and this and this to prevent this issue. You can, in all ways, fix it. You mount it outside on a tall rise building or something. Lightning strikes the board. I mean, you couldn't cover up at that point, right? So you have to come back to learn and then adjust your device. So for me, my advice would be it will come with experience, but just do what is right. Do what works. Don't overdo anything on the design or schematics PCB. Do what works and then you should be fine. Right?
Okay, thank you.
Welcome.
About the calibration. Second one is the estimated lifespan of this local sensor.
Yes. So the estimated lifespan is a combination of every component you put in there. So your PM sensor has its lifespan, how long it can run. Some can go for 6 months, some can go for 1 year, some can do 2 years, but it means you have to come back and recalibrate. Other sensors have their lifespan. So as an engineer or technical person put this together, you have to consider the lifespan of the sensor you should be using to increase the longevity of your sensor. Also, it's not always about the sensor, again, the enclosure, right? If you have a proper enclosure and a certified enclosure that is water resistant, heat resistant, you can protect your sensors from the external factors that reduce their lifespan. So in designing, enclosure has to be one of the things you consider. Okay. Welcome.
Yes, so in your presentation, I saw that the sensors are normally mounted from 1.5 meters to 2 meters. What if someone mounts the sensors beyond these 2 meters? What will happen?
Okay, so when so I was saying 1.5 meters to 2 meters, that is the optimal range you can actually measure the concentration of gases or particulate matter you are taking. Anything above that may be off a little, because this is what we have tested. And then for our sensor, that is what works. That height is the optimal height to allow you measure the parameters you want to measure. So anything above that, maybe based on environments, can affect your readings too. So that's why we keep it in that range. Okay. All right. Okay. Thank you guys very much. Thank you for having me. I hope you enjoyed the session.
Okay. So the last presentation for the day will be presented by Mr. Ibrahim. Mr. Ibrahim Anyas Yussif. And he's going to take us through assembling of low-cost sensors, that is Airgradient open-air sensor. Mr. Ibrahim is an aspiring atmospheric scientist dedicated to advancing the field of scientific research. With a strong academic background in physics, Mr. Ibrahim is passionate about leveraging his expertise to make significant contributions to atmospheric and environmental sciences research work. Currently, he serves as a data analyst for Afri-Set, where he applies his analytical skills to address critical issues related to air quality and sustainable development. Ladies and gentlemen, please put your hands together for Mr. Ibrahim.
Thank you very much. All right, so first, let's pack the previous kits. Let's make sure all the components are fitted back before we proceed to our session. All right, so good afternoon. All right, so this is the last session for the day, and we can go and have our little and plenty snacks. All right, so I'll be presenting on Airgradient open air sensor kit. So it's basically a hands-on practical sensor building. Similar to what we just did, we are going to use Airgradient air quality sensor 01 PST. All right, so I believe on each table, you are all having a unique box from Airgradient. And in it, please, next slide. All right, so in it, this is how the Airgradient sensor actually is. And I believe most of us are quite familiar with what, the Airgradient sensor is. All right, so to begin with, it has a user-friendly interface. That is the first thing. It also has a unique durability. Oh, okay. All right, so Airgradient also has a unique durability. Unlike other sensors that weather during harsh climatic conditions, this sensor tends to remain more like hold this, color, within varying climatic conditions. And after this session, you realize how easy it is to build or assembly an air quality sensor. All right, so to begin with, each box should contain something similar to this. In it, figure 4, we are going to have a plant tower. Similar to the particle sensor we just used, this is a plant tower. And also this one is Sense S8. So these are some of the parts that you should be seeing in your box. And also this guy is also a PCB board. And one of the interesting things is that it is the board that will take most of our time. All right, so in it also, we must also have JSK connecting cables. So in total, your cables should be 2, along with a screwdriver, and some screws in here, and also our TVOC and NOx sensor. All right. So please do check and let us know if you miss any component in there. So please do check inside the container. All right, so please do check inside. You will see everything has been packed in it by the previous guy. So, all right. So I believe we are all set. We have the various, parts that we need to move on to the next step. Please, is any table missing any component? So I'll take it as we can move on to the next step. All right, so ideally, after we've assembled our kit, this is how the device should look like during the process. So here we have our PCB board, and on it is going to fit inside the base of the Airgradient. And on the PC board, we are going to have a section called, this part labeled status LED. And on that same PCB board, we are going to have a USB Type-C power, connecting cable in it as well. Aside from that, we are also going to have an ESP33 mini controller. Since it's a Wi-Fi model device, we are expecting that this PCB board should be able to broadcast its, Wi-Fi, similar to what we just did. So there will be a broadcast of Wi-Fi. You will see an IPI. You will see an Airgradient associated with its equivalent ID. That is the unique thing about, the sensors you are holding. Each of them, even though the case doesn't have any inscription on it, but each device will broadcast its unique identification. And at the end of this, we'll show you a dashboard, Airgradient dashboard, whereby you'll be able to identify if your sensor has been connected to the cloud or to the Wi-Fi and is streaming data real time. Please, do anyone have a question? If not, okay, I'll move on to the next one. All right, so we are starting. All right, so first, you connect the SGP4. In the component that you are having, there's a part labeled SPG4. can you identify the part SGG4? All right, so SPG4 is the tiny, how do you call it? The tiniest component in it. So please take note. The bigger one is, how do you call it? The sense S8, right? So SPG4 is the tiniest of all. It's very tiny, so please make sure you identify it. All right, so on the PC board, there's a pin holder labeled 12C1, right? Along with your SGP41. So you know that, you realize that there are 4 pins. So these 4 pins goes into the 12C1 holder. So please, yes, like my guy said, check them. So please fit it gently. Hey, please, not anyhow. I beg you. I beg you. All right. So the pins should be facing down, right? All right. So the next step is to screw the Sense S8 and connect the longer cables, of the 2 supply kit. Yes, you realize that you are having a component called Sense S8, right? So after fixing your pins on the PC board, you are having a container, right? You fit it in there before you place your Sense S8 or Sense S88 onto it. All right, so the PC board, right, goes into this container. This doesn't require any screw yet. So you realize that there's a section for where each pin and the LED and also the Type-C USB should fit on the board. Yeah. Yes. So once done, we connect the Sense S8 onto the board, and with the screwdriver, along with the smaller screws, we screw it onto the board. So onto the board, you are supposed to see a section where, you'll be able to fit the screws. That's the only part with a head where you can, fix. Yes. Yes, so please screw the Sense S8 onto the board. All right. My guy, hold on. No. So remove the cable. So connect this guy here.
Yeah.
And screw it.
With this.
Yes. Yeah. Good. Yes. Oh, you have only one? All right, but I mean, it's fine. It will hold it. Yes, it will hold it. All right, then. All right, so once we are done, the next step is to connect the plant tower onto it. So the last place is where the plant tower is going to. Yeah. Please, you need help? Yes, we are. You're okay. You are on the good track. All right. Good job. Dr. Alassani. Oh, so yeah. So please, where's the PCB board? All right. So please fix this guy back. All right. So we are good to go. So the next one is we are going to connect the plant tower in here, right? So yeah, depending on how you want. All right. So once done. Okay. My guy, you've been able to screw it. Good. All right, that's nice. When you are done, you place the plant tower onto the board. Then you fix the connecting cables to it. Sorry. All right, so okay. So once we've placed the plant tower on the board and connected it with the other cable, right? The cable goes to P1. The particle sensor goes to PM1 on the PCB board. So there's so, my guy. So, plant tower goes to PM1 on the board. Is it this guy goes to the PM1 on? So check for where PM1 is.
Yeah, so we should remove this one.
So check. There's PM1.
Let me see. Okay. PM1.
So the plant tower cable goes to PM1. You see, there are two connecting. This PM2, right? So the sense air. So PM1 goes here. So
yeah, that's what we did. Yeah.
All right then. So please. Are we all good? So we've been able to connect the particle sensor to PM1 on a PC board. All right. So the same goes for the Sense Air S8. It goes on to the PM2. Okay, we are on the same page, right? So we should be seeing something like this, isn't it? Figure 7 here. We should be seeing something similar to this. If all the cables and all the parts are fixed right, this is what we should be seeing. All right. So the last step is to close the enclosure with the white cap, right? So you fix it gently. So please, behind it, there is a hole, right? There is a hole. The hole should align with the hole behind the base. So on the base, there's also a hole here, right? So each hole should align. Otherwise, you will tear our cables for us. All right, so gently. Yeah. All right. So after that, we turn it upside down and we fix the remaining screws there. To fix the whole thing. Hetty, gently. Gently, yeah. Okay, so once done, once we fix the screws to the board, to the enclosure, all we have to do is to connect the 4-meter cable to it. Allen key, only Allen key. So, Paul, your group is done, right? All right, so let's draw our attention to Paul's table first, right? No, so Paul, you can put it on the table. It's fine there. Yes. So please plug it, give it power actually. No. It will come on. So yes. So once it has power, it will blink twice. But first, before the rest of us do that step, I want us to test something first. So they've connected it to power. We all should be able to see the device broadcasting its, how do you call it, signal or Wi-Fi. So we can all take our phones and try and see if we can identify the Airgradient underscore the serial number. So your phone first, take it, go to Wi-Fi, try and see if you can see any Airgradient sensor broadcasting. That is this. Right? Your own two is on. All right. So I need only two to be on. So I need only two Airgradient sensor that has been assembled to be on. Hey, three. Measure one. One. So can you disconnect it? Yes, just disconnect it first. All right. So once. So Thomas. All right. So connect to your devices. So how many IDs are you seeing? 3 now. Oh, so guys, please, how many devices are on? I know yours is on, theirs is on. Has any other any table or any other table? So Ima, Abeg, can you turn off yours? It's off. So we should be seeing 2. It's 2 now, right? Okay. So connect to 1. Right? So tell us what you are connecting to. Airgradient what? So guys, please, he's speaking. All right, so please, 34 B7. All right, so that is the Airgradient underscore 8 serial number, isn't it?
Yes.
All right, so then the other Airgradient is what?
Hold on.
Check. I know yours is on, right? So please tell us your device's ID.
Okay. The another one is Airgradient dash D83 BDA 1C5638.
All right. So these are the 2 Airgradients that are online, right?
Yes, please.
Sure, that's fine. So Airgradient has a unique password, which is the clean air, lowercase. So once yours is on or powered on, and it's broadcasting the Airgradient underscore or dash the IDs, this should be your unique password. Clean air. Right? So once you connect to it, it will allow you to enter your password. And please type this password there. It's clean air in lower cases. Yes, in lower cases. All right, so once connected, it will send you to this IP address. So Thomas, are you connected to one?
Yeah, I'm yet to connect.
All right, check.
Yes, sir.
You're also connected to one, right?
Okay.
Yes, but now we are working on only 2 sensors.
Now we have another one joining too.
Another one showing.
Yes.
Interesting. So, all right. Okay, so guys, let's follow the step as explained earlier. Let's connect to it and type in your password, right? And after that, you move on to the IP address here. It's uniform for all. once you are connected to a particular Airgradient device, it will open a dashboard with this unique ID, and you configure it to a Wi-Fi. So here we have the Monarch Hotel. You also have the MTN 2G, 5G Wi-Fi around, isn't it? So on the walls, the passwords are there, depending on what you want to configure it to, right? So once all is done, the next step would be a dashboard that will know if any of the sensors is online now or streaming data. All right, so it would be nice if each table, one person does it for the table. So we don't get a repeated, access to a particular device. Oh. All right. My guy. Dashboard. Dashboard, yeah. Okay. So, dashboard. It's connected. So, you go to the, how do you call it? The IP. Configure Wi-Fi. Yes. Yes. No, for the Wi-Fi, you use the available Wi-Fi as password. All right. So this is the cleaner is the one you are going to connect to the device. So
You have one.
Yeah.
So cleaner is for this.
It's connecting to something.
Okay,
Yeah, then 8902000.
It's supposed to just.
You should be seeing connected without internet. It's a good thing, right? So then you go and you input the IP address, the 192.8 something. Then, you go to you follow the next step. You should be seeing saving credentials, and the device will try to connect to the network that you've input the password to. So now we should be seeing these areas should start lighting up. Yes. No, not yet. But once it's connected, it should start coming up in a bit. Still, yours is not showing. It's not showing. You didn't. No, so do. Yeah, I mean, please do. Right. All right. They've connected it, right? All right, that's fine. And you've configured it to a Wi-Fi. Try again. The Wi-Fi is not working. You can try configuring it to another Wi-Fi. So if once connected to a particular Wi-Fi and the device is still not transmitting data, the device will still broadcast its Wi-Fi, right? After several attempts to try to transmit data, it will still broadcast its Wi-Fi. So you get a chance to also configure it to another Wi-Fi since the first one didn't work. Okay. You can try configure it to any of the MTN or the Monarch's, hotel Wi-Fi that is broadcasting. So I think each of them should have, great connection. So still, none of the sensors are showing, meaning that the, the configuration of the Wi-Fi, even though it has been done, but maybe the Wi-Fi is on low data or something, right? But my guy, can you click on any of them? Yeah, just this one. Yes. So once the device comes online, we should be seeing readings like this, right? We should be seeing that. We should be seeing readings, live readings from the device. So as of now, none of the sensors are online. Yeah, so let's try and cross that bridge so we can display each table's streaming data. The setup is still here, just in case you want to follow that steps again. So it's here for your, for your attention. Once we've done the connection, this is how the dashboard should look like. We should be seeing data streaming. And I understand that there's a bit of a challenge with the internet connectivity. So some of the sensors, once connected, still blink, indicating that the signal is not that strong. So the device can transmit data. But once the device is able to transmit data, this is a clear example of what we should see. And with this, please can you go off the screen? Top. All right, so a little bit, yes. So here, you should be seeing your PM concentration. You should be seeing your PM 2.5, PM 110, the CO2, the temperature, relative humidity, and the SGP4 sensor we connected, which is giving us an index of the TVOC and that of the NOx, right? So once everything is connected and is ideally transmitting data to the cloud, all these sections should be filled like this relative to the time it transmitted. All right, so I think that ends the day for this session. Thank you very much. But before that, the last thing is let's unassemble it, right? Yes, so that the next people or the next set of badges who, yeah. Oh, so please, do any of you have any question that you'd want to ask? So any questions, please? Any questions, sir? All right.
So what I can see is that this model, I see that there is a problem with a little bit of problem with the connectivity. So is there a way to, let's say, if somebody has already connected to an internet and then connect to this model, a way to make it such that it will be easily to sync with that internet instead of manually entering it? Because I noticed that that's one of the problem. And additionally too, I noticed that you connect, and whilst you are doing the setting, it disconnects on its own. So I don't know if the internet setting is not strong enough.
So does this have to do with our internet connection here, or does our internet have anything to do with it?
Okay, so to answer your question, this is why we use this as a demonstration, because we realize, in other countries, the whole city has a Wi-Fi. Now, in most cities in Africa, we don't have Wi-Fi. And so the Wi-Fi model at times is a challenge if you don't have a stable internet connection. And so that is why with this sensor manufacturer, we would suggest that you use the GSM model, then the Wi-Fi model. The GSM, all you do, buy your local SIM and put it inside, and you are good to go. Okay? So we bought this as for demonstration purpose, because the GSM model comes fully assembled. It comes fully assembled. But for this one, the Wi-Fi model, it's broken down to train people how to just connect it. So because we don't have a stable internet, so we have this challenge. But I think if some of you have your mobile phones, you could try hotspotting to get it to work. The last time we organized this, that was on the University of Ghana campus. We had a stable internet service, so all of them could see and how the data was loading. Okay? So this is just a broken down one for demonstration purpose. But they have, and this company is one of the companies that we have evaluated all the different models. We evaluated the GSM model on the University of Ghana where we are located, and because we have a stable internet there, we were able to get all the data, within the 6 weeks of the dry period and 6 weeks of the wet period. We also have evaluated their GSM model, okay? And we are in the process of getting them to send us the latest model, which is one which has GSM, but this one now has solar facility added to it. Yeah. And the Airgradient brand for now is what we are going to use to start the microsensor challenge. And you'll hear a bit more about the microsensor challenge tomorrow. It's in the session. And so this is just one of them. We have other manufacturers who are now reaching out to us that they want to have, to be a part of the, sorry, did I say microsensor challenge? Yeah, sorry. It's the sensor loan library. Sensor loan library. So they are the first manufacturers we are using for our sensor loan library, and then others will come in later. So I don't know whether that have answered your question. Yeah. So if you have any other question, let's bring it on. Yeah.
Just a follow-up. Yes, the GSM model, I agree with it. The one thing I would just add to that is we had some similar thing in Kintampo where a GSM model was used, but what we noticed is that it requires a specific GSM model based from the manufacturers from the US, which was also another problem. So maybe when you are talking to them about the GSM model, it should be one that, even if it is in Ghana, MTN SIM card will also accept. Thank you.
Yeah, so I'm aware of the situation in Kintampo, and we are working with some of your people in Kintampo to see how we can solve that problem. Your sensors that you are using is working with the GSM model, but they have an international SIM card. And apparently, that is why you are having the challenge. So we are also talking to that manufacturer to see how best they can operate with the local SIM. And I think one of the things they said, because when my research associate met them last week in California, they tried to give some reasons why, we are having challenges here in the tropical environment. It has to do a lot with the temperature. Yeah. So I'm aware that, but we have had experience with other manufacturers who have brought their international SIM and it works. And some too, we had to use the local SIM. I think one of those manufacturers, I think is in the room here, right? Yeah, we had to now put in our local SIM. And even with the local SIM, it's not all the local SIM, our carrier. So you need to try and get the one that matches the design of the manufacturer. And in one instance that we had to get the sensor manufacturer to send us a device to reprogram to be able to work with the local SIM. So these are some of the challenges we'll face, because a lot of the manufacturers are out of sub-Saharan Africa. And so their design was for their environment. But now these sensors are making their way here, and that's why at Afri-Set we are set out to evaluate them in our environment and our climatic conditions to see how well they work. Because where they are manufactured, they work very well, they have been tested. But we want to find out that when they come here to Africa, especially to Ghana, to Accra, that we find ourselves close to the equator, where we have variable weather phenomenon, very high temperature, high relative humidity. How will they work? Our sources of pollutions tend to be a bit different from what they have there. In some places, they sweep their streets every day. They wash their streets. Ours, we don't even have the streets to wash. It's all full of dust, you know, and the sensors are absorbing whatsoever is in the air. And sometimes you find that the effect, I think someone was asking about the lifespan of the sensor in the previous section. So it affects it, all right? But for some of the sensors, it's easy to purchase the plant tower and change it. I think you saw the plant tower, the blue one. So usually with this manufacturer, you can just change the sensors when it starts to degrade, and you get a new one working. So it continues. And one other important reason why we are using this manufacturer for a start is because their data is open. And immediately you install it, the data is on OpenAQ, so anyone can download it. So they don't sell data. A lot of the manufacturers are selling data. You buy the sensors, after 1 year, they say you have to go and renew the license. And we had yesterday that when we say low-cost sensor, I mean, in this part of the world, if you say a sensor is about $100 or $200, I mean, for some people, it's not low cost. It's quite expensive. It's like 2-3 months' salary. But in comparison with the reference monitor, which is in the thousands of dollars, it tends to be low cost. So for us, we refer to them just as air sensors. We don't even say low cost sensors. They are air sensors to dispel that issue of low cost being affordable. So that's one issue I wanted to just point out. Ibrahim, we want to add more.
So, like you said, the Airgradient also have firmware, I mean, on their website or on their dashboard, that if you are having a challenges using the GSM, you can easily flash it, I mean, with the USB that you have. You connect it, you download the software, then you run it on the device. And I mean, it will correct the issue that you are having with your, I mean, the connectivity when you are using the GSM. All right. So, I mean, is there any other questions that needs to be asked and any clarifications will also needs to be made? All right. Thank you for your time.